ads and win. Mine is an incredibly powerful 3D modeling package. And even back in 2004, when I first started still find myself finding within 2 or 4 online videos very deep, good old books. Kind of like, but here's the thing, tutorials don't just spend fewer ads years to become a buyer. Mine is an incredibly powerful, that's why I created this video. And even as showed 2004, when Maya started following secrets and finding within 2 or 4 online videos, you can shortcut the process. Good old books. Kind of like, but here's the thing, what's going on, don't just spend fewer ads years to become a buyer. Damn, you see, bro, I'm a professional video artist. Mine is an incredibly powerful, that's why I created this video. And even as showed 2004, when Maya started following secrets and finding within 2 or 4 online videos, we get started, I want to let you know that registrations are now open. Going on just for fewer ads years for training. We'll dive in even deeper into 3D modeling. And now why is it through my simple step-by-step process to create promotional models for the language language jobs. Join over 10,000 students started. I want to let you know that registrations are now open. This is limited time of ads for your training. Register now using deeper comments on 3D modeling. And now why is it through my simple step-by-step process to create promotional models for the language join over 10,000 students started. I want to let you know that registrations are now open. This is limited time of ads for your training. Register now using comments on 3D modeling. And now why is it through my simple step-by-step process to create promotional models for the language jobs. Join over 10,000 students started. I want to let you know that registrations are now open. This is limited time of ads for your training. Register now using comments on 3D modeling. And now why is it through my simple step-by-step process to create promotional models for the language jobs. Join over 10,000 students started. I want to let you know that registrations are now open. This is limited time of ads for your training. Register now using comments on 3D modeling. And now why is it through my simple step-by-step process to create promotional models for the language jobs. Join over 10,000 students started. I want to let you know that registrations are now open. This is limited time of ads for your training. Register now using comments on 3D modeling. And now why is it through my simple step-by-step process to create promotional models for the language jobs. Join over 10,000 students started. I want to let you know that registrations are now open. This is limited time of ads for your training. Register now using comments on 3D modeling. And now why is it through my simple step-by-step process to create promotional models for the language jobs. Join over 10,000 students started. I want to let you know that registrations are now open. This is limited time of ads for your training. Register now using comments on 3D modeling. And now why is it through my simple step-by-step process to create promotional models for the language jobs. Join over 10,000 students started. I want to let you know that registrations are now open. This is limited time of ads for your training. Register now using comments on 3D modeling. And now why is it through my simple step-by-step process to create promotional models for the language jobs. Join over 10,000 students started. I want to let you know that registrations are now open. This is limited time of ads for your training. Register now using comments on 3D modeling. And now why is it through my simple step-by-step process to create promotional models for the language jobs. Join over 10,000 students started. I want to let you know that registrations are now open. This is limited time of ads for your training. Register now using comments on 3D modeling. And now why is it through my simple step-by-step process to create promotional models for the language jobs. Join over 10,000 students started. I want to let you know that registrations are now open. This is limited time of ads for your training. Register now using comments on 3D modeling. And now why is it through my simple step-by-step process to create promotional models for the language jobs.
No
Guys, Actions figure out how many degrees of rotation you need. Well, again, Blender can do calculations within its parameters, but I'll show it to you here in the calculator. 360 divided by your symmetry lines, which is 6, it's going to give us 60. So this slice is going to have to be rotated 60 degrees. That leads us to our final step, which is the setup. For this setup, we're going to need two things. We're going to need a empty and we're going to need an array modifier. So I'll get the empty first. Shift A, empty. We'll do plane axes. It's going to drop there in the middle. And now we'll select our slice here. We'll add another modifier, and this is going to be the array. By default, this is going to be off because you actually don't need a relative offset. So we'll shut that off. We'll use a object offset here. We'll pick this empty here. And you see that it's off in La La Land. Well, why is that? Well, that's because of our transforms again. So what we'll do is we'll hit Control A. We'll apply all our transforms. And there we go. It cleared that out. And now if we start playing with the count here, nothing's happening. That's because we don't have any rotation. So when we start inputting our rotations, you see this starts to work. And remember, we already figured out that number. So it's going to be rotations in the Y. And I didn't constrain the axes here. That's why I'm getting some added rotation values. But I'll put 60 here. And you see now that this is working properly. So we'll go back to the array and we'll get our count to the right number, which is 6. And this is pretty much it. As long as we work here on half of the slice, you'll see that all these details are actually reflected here. Now, one thing to keep in mind is you want to respect this boundary edge as much as possible. Something you can do is you can tap G twice and slide your components along here, and that way you're not getting into any trouble by pulling off this surface. What I'll do from this point is show you a little bit of the modeling process, so you'll see how fast your shapes can take form with this setup. What I'll do from this point is show you a little bit of the modeling process, so you'll see how fast your shapes can take form with this setup. What can I say? You're on a roll. You made it to about the halfway point of this video. Just for hanging out with me today, I have a free gift for you. I put my years of professional experience into creating the Hard Surface Cheat Sheets, a 3D modeling guide that will kickstart your hard surface modeling. Download it for free using the pinned comment down below. Ever come across a shape with lots of repeating details that is supposed to be merged to a less dense part of your model? It can be a pain to try to match the two different densities of meshes, especially if you're trying to get clean results. Well, not with this next tip. Tip number 3 is pattern match merge. This rifle grip is a perfect example for this workflow. We have a couple of potential issues that this workflow really alleviates. We essentially have this grip pattern that has a lot of details going into this much less denser part. So the first thing that you'll see me do, even before I get to the nitty gritty of creating that initial detail, is I'm actually shrink wrapping this via shrink wrap modifier, this little bit of a base onto the main shape that it's going to be merged to. The last thing that you want to do is create this pattern, and when you go to merge it, you have some inconsistencies. Now I know that this base is going to be aligning with the bigger shape that ultimately it's going to merge onto. The second thing that I want to do is use those instances, in this case it's going to be an array modifier, to create a pattern that's flexible. So now I can flesh out this shape.
Read, memorize, repeat.
Don't ask questions, just mark the answers.
Just by heart it.
This is not the way. You should not do it like this.
Just by heart it.
And pretty much align it to where this pattern is going to fit. So once I have my pattern finalized, I can then pose it back into place and tackle the next step. In this part of the workflow, we're we're trying to match up the two densities, right? We have a very detailed part that's naturally going to require more density. And then we have this larger part that doesn't have as many details, but in order for a sub-D workflow, these densities are going to have to match up a little bit closer. So what I need to do is treat this larger part and add more subdivisions to match before I do my merge. The key here is that we're going to have to actually reinforce some of these edges first. Select all the edges that need to be hardened or reinforced and set those edges to a mean crease of 1. That's going to allow us to hold up our shape once we introduce our added divisions. So on this base mesh, we could add a subdivision modifier and actually bake it in. Now this is going to get our divisions a lot closer to each other. Now we could simply join both of these pieces and start welding these verts. So after a little bit of manual cleanup and matching up those edges, we were able to take this pattern, create it separately, and then merge it onto this larger shape for a sub-D workflow and get ultimately clean topology. We're down to the last 2 tips and they just keep getting better from here. The next one will change the game on how you create hard surface cables in Blender. Tip number 2 is duplicating the form. This is a great workflow for creating hard surface cables like this. And to pack as much value as humanly possible in this video, I'm actually going to show you 2 bonus tips that pertain to this specific example. One is going to be able to actually reverse engineer a curve right in the middle of a cable like this. Why would you need that? A lot of times you get models that you ultimately have these cables for, but no curve to control, especially if that modeler deleted the history and those curves. This will allow you to take a cable like this that you don't have a curve, create a curve, and then link that curve back to the object and have something that you can rig and control that curve once more. The second tip that I'll be showing you is using the curve warp modifier, which is essentially what we'll use to create this final object, but use it in a pose position. A lot of the tutorials out there that I've seen use the curve warp, but everything's lined up in the world and everything lines up perfectly. When you're posing and having these curves kind of in the middle of your scene, there's specific settings that you'll need to have your object and also your curve warp modifier when trying to get the curve warp to work with a curve that's off in 3D space. Let's get started. The first thing that I'll do is isolate this curve. And what we're going to do is dive into edit mode. We can kill the sub-D modifier. Essentially, what we want to do is just pull off a strip of topology here to create the basis of the curve. However, the problem here is that this strip right here, assuming we didn't have a curve in the middle, is not in the middle of the object. So that's going to be the first task that we need to do. I'll go ahead and actually separate this first. So I'll hit P and I'll do by selection. And now these are separate objects, so I can go ahead and delete my original mesh and be left with this alone. Now, we want to simplify this object because eventually it's going to become an edge that's going to become a curve. In edit mode, I'll select one vert, and then I'll hit A, select all my verts, and now I can hit M and do a merge by distance. Essentially slide this up. I'm going to crank this up just a little bit more, and now we have a perfect edge flow here that's going to allow us to do the next step. I'm going to bring everything back because I'm using basically this middle point here and this middle point here to gauge how close I'm in the middle of essentially this shape. And we have this old construction curve. I'm just going to hide this. That way we don't get confused. So now again, we'll dive into edit mode, one vert, hit A for all. And now we're going to do Alt S is going to allow us to push and pull along the normals here. And now you see that this is lining up pretty much in the middle here and the middle here. So now if I do Control R to add a loop cut, double click, you see that this is pretty much in the middle here. That's exactly what we wanted. And if we wanted to fine tune this again, I could also just select all this again and do Alt S and just push and pull along the normals just a little bit more. And it gets us that little bit closer to the middle of these two caps. I think this looks pretty good. Now, again, I'll hit P and then I'll separate by selection. And at this point, now we could delete this strip. And now we're left with this edge. This edge is going to be converted to a curve. So I'll right click, convert to curve. Make sure that you're on object mode. Now we have a curve. Next step is to change the way this curve is being interpolated. For that, we need to dive into edit mode and make sure everything's selected. We'll go down to set spline type and then we'll do a NURBS curve. And now this is a smooth curve. If you leave this faceted, then when you do the final step, you're going to get a faceted result with your object here being deformed. Now, one thing you might notice is that we lost a little bit of volume here when this became a NURBS curve. If we go to wireframe here, something we can do is working with NURBS curves. If we just select both of these verts here, or these points, and then we do a subdivide, you see that it gets us a little bit closer. So if we wanted a little bit more continuity here, if we just divided that a couple times, we get a little bit closer to kind of our cap. And then ultimately we can just take these points here and just kind of move them into place. And there we adjusted the curve. Now, if for some reason your curve has too many points, depending on what geometry you pulled it from, Blender does have an add-on that will allow you to essentially rebuild or simplify the curve. Under Edit, Preferences, and if you search for Curve, you have the Simplify Curves add-on. This ships with Blender, so just enable that. And if you want to simplify, just make sure that you're actually in edit mode. You can right click, you can curve simplify. And now if we play with this error here, you see that we're losing quite a bit of volume here. I actually like the curve that I originally had, but this is an option if your curve is a little too dense and you want to basically simplify it. Next thing we'll do is build our pattern. So I'll isolate this curve. I'll do Shift A mesh. We'll get a cylinder in here. We'll keep this pretty simple. We'll drop this down to 8, scale this down quite a bit. I'm pretty much eyeballing the scale of this object with that scale of the curve, but at the end of the day, it doesn't matter since we're going to be using modifier stack. All this is going to be pretty non-destructive anyways, and the height will be adjusted. Repeatable pattern here. We need to inset both of these at the same time so this works properly. And then here, I'm simply going to extrude, push out in the Z here just a little bit, and this is going to get deleted, and so is this. And now we have pretty much this shell that's going to lend itself well for our repeatable pattern. We'll do a couple of bevels here just to shape this a little bit better. I'll just do a bevel with Control B. And then here, now that we have these faces selected, we could just convert this. We'll go to Select Loops and then select Boundary Loop. And now it basically took that face loop and converted it to a edge. If you're a Maya user, this is the same thing as Edge Perimeter. So this looks good. Now we need to do a bevel here with 2 divisions and make sure that this is, since this is a holding edge, we just want the shape of 1. That way, if you ever need to go back and delete these bevels, it's a non-destructive workflow. And remember, if you're doing bevels and things are a little bit wacky, just make sure that you apply to your transforms. Here, I don't have any scales. I do have scales, but they're all even. But if you had uneven scales, this would kind of bleed into your bevels. So always remember when doing bevels, especially if they look a little bit funky. I'll do Control R here. This is going to be bent along a curve. So we need a couple more divisions. I'll set this to 3. I think this will work pretty good here. All we need now, we'll go to object mode. We'll apply a modifier and we'll drop the array. This needs to go in the Z. So we'll zero out the X, put a 1 in the Z. Lo and behold, we have a pattern, hip array. Terrible joke, but great result as this is working as it should. Put this to 25 and then we could always increase this once we drop it into the curve. Right now it is feeling a little bit big compared to that curve, so I'll scale this down just a little bit. I think we're ready to drop this. The other thing that I'll want to do is since these verts are not merged, we could always add weld modifier, and this is going to weld our verts. And then we'll also add a subdivision modifier, but we could just do Control-2 for that. Right click here, shade smooth, and disable it here in edit mode. And that's why I always like to just add my sub-D modifier, and it will kind of expose any weaknesses. And here we forgot to account for the edge loop here within our base pattern. So we'll just find that original one, and all we'll have to do is go in here and just add a loop here, and then also a loop here. And that's going to be actually at the bottom of this, like this. And now this looks pretty good. All right, so let's go ahead and deform this. We'll need to add a curve deformer for this. This needs to go above the sub-D. We'll simply select our curve object. Now, a little bit of a warning here. If we look at our curve, and I had to find the origin here, but I can tell you right now, this is not going to work. Why? Because our curve origin is off here in La La Land. It's off in space. So that's not going to work. But the object itself, it's fine. We just have a scale here that's not going to affect anything. And it was created here within the origin. So that's ultimately where you want to create that repeatable pattern. But to get this to work properly, we need to have the curve's origin within the world origin. So I'm going to run it like this, and you're going to see how it's messed up, and then we'll troubleshoot it. We'll select our object here. And then under the curve warp modifier, we'll simply select the curve, and then we're going to get this wackiness going on. This is a telltale sign that your curve warp modifier is not working properly. Your deform axis is going to influence this to a certain degree, but if you did this right, usually your object will snap to the curve's end, regardless of its deform axis. Now, I can hold down Control and kind of scrub through these, and you see none of these work. Now, I'll select my curve, so I'll go to Object, Set Origin. We will do origin to 3D cursor. Exactly what I said would happen. Your object is snapping at the end of the curve, and its origin is right here in the middle of the scene, which is pretty much what you want. The only thing that we have to fix is the form axis. So again, Control, middle mouse wheel, scrub, and there we go. The Y is the axis that's going to work for you. Feels a little bit too big. Let's actually bring everything back and see how it looks compared to, yeah, just a little tad too big compared to the other one. Not a problem. We'll simply go back here. So we'll isolate this once more. We'll hide the curve warp, and we'll simply just scale this down a little bit. Since we scaled this down, we're probably going to need a little bit more on the count. Let's see how this looks. We'll bring everything back, and we'll turn the curve warp back on here. You see that we're just a little bit short now that we changed the scale. We can just plop this up a couple times, and this looks pretty good here. So the great thing about this workflow here is that this is all procedural with modifiers. So if you want to do any changes here, this is very simple. Again, we'll go back, we'll disable the curve warp, and we'll isolate our selection. We'll dive into edit mode here. For example, if we wanted maybe a cool little panel line, all we'd have to do is maybe just drop a couple edges here. I actually just did this with the bevel. Select this loop of faces here. Alt-E. We're going to do extrude faces along the normal. And then we'll just push in slightly here. We'll go back to select loops, select boundary loop. And now these are the edges again that we want to drop another bevel just to reinforce this little inside corner. Now, if we enable our sub-D modifier here, now you see that we have this nice little panel line. And if we bring everything back and we enable our curve modifier in object mode, we see the result. And you see how flexible of a system this can be. I don't like that extra panel line. I think it's a little bit too much. I'm just going to undo all that, enable everything again, and turn my curve warp on, and we're back to square one. Now, the beauty about this setup is that if we have any other cable, maybe like a steel cable here, this is very easy to just create another pattern and snap it with another curve deform. So we have this cable here, and now we have, again, the same setup here with the curve deformer. We'll just preview it, and there we go. Look how easy that was. And now we have a completely different pattern here that we have going on. I'll enable our original once more, and I'm pretty happy with the result. Yeah, baby, you made it to the last hard surface modeling tip. I know you're serious about becoming a 3D modeling beast. While Blender has some serious, powerful 3D modeling tools, the ability to change primitive divisions after they have been created, it's not one of them. This can be extremely frustrating if you're coming from a 3D modeling app like Maya that has this ability. But I found a sneaky way to turn one of Blender's weaknesses into his strength. In my Have you ever spent hours creating what you thought was a great hard surface model in Blender, only to realize that it's full of shading issues like pinching when previewing your final version? Pinching is one of the most common topology mistakes beginners make on the 3D models, an issue mostly found on curved surfaces. Over the last couple of years of teaching artists how to master 3D modeling topology, I developed a simple 4-level system that will help you get clean topology without shading issues, even on the trickiest curved surfaces in Blender. While be using Blender, these principles apply to most 3D modeling packages. What's going on, you 3D modeling beasts? This is JL Musi. I'm a professional 3D artist with well over a decade of experience. I created educational content for companies like Autodesk, and my 3D software reviews have been featured in PC Mag. I specialize in creating sub-D models with clean topology, and I created the most watched hard surface topology video on YouTube. Before we get started, I want to let you know that registrations are now open for the Hard Surface Masterclass. In this free training, we'll dive in even deeper into 3D modeling, and I'll walk you through my simple step-by-step process to create pro-level models that will help you land your dream 3D job. Join over 10,000 students who've already leveled up their skills in my previous classes. This is a limited time event, so don't miss out. Register now using the pinned comment down below. Let's get started. I'm gonna create a cylinder here. So I'll do Shift A cylinder. We're gonna start with 24 divisions. I wanna pop this up 1.25. This is actually going to make this a little bit longer. Then we also want to pop this in the Z here. So I'll hit 1, then G, Z, move this. I want to move this 1.25. So just as a standard workflow, I like to have everything over my ground plane. Now, within edit mode, I want to delete these 2 caps here. So I'll hit X, delete faces. From this point, I want to have nice even quads. This is going to help us punch in our detail. So for that, we're going to do Control R and drop some edge loops. This doesn't have to be perfect, but we essentially want to make these nice squares right here. With our base shape created, we're now ready to master topology on curved surfaces by tackling 4 key levels. Each step builds on the last. So make sure to watch all the way to the end to get the full picture, how to achieve clean professional topology. Let's get started. Level 1, edge flow. Edge flow plays a crucial role whether or not you'll see shading issues, especially around corners. This is one of the most common causes of pinching on curved surfaces.
প্যাচ প্যাচে গরম এলো, ডার্মে কুল আরাম দিল। নিম আর তুলসী যুক্ত নতুন ডার্মিকুল ঘামাচি দূর করে, ঠান্ডা অনুভূতি প্রদান করে।
Ready to dominate the tables? With GTO Wizard, the world's #1 AI-powered poker solver, you can instantly study any spot in cash games, MTTs, and spin and goes. Build custom solutions for your games, accounting for factors like rake, annies, or tournament payout structures. Plus, you can upload and analyze your hand histories with just one click. Beat the best, crush the rest at gtowizard.com.
Now, any edge loops here running perpendicular to this curvature, we're not going to have any issue. So here, I'll add an edge loop here, right? And we could even add another edge loop here, or a loop cut as it's called in Blender. And then in object mode, if I do Control 2, add a subdivision modifier, and we'll do right click to shade smooth. We can hide the wireframe. You see that we have no noticeable pinching. Now we go back into edit mode. And what I like to do is actually disable my sub-D modifier within edit mode. But now if I select a loop here that runs parallel, right, or with that curvature, and let's just say we run a bevel with 2 divisions, this becomes very evident, right? Now we can see this a lot better with something with a little bit more specularity. So this red matte cap material, you see how noticeable that pinching is, and even though we have the same exact edge flow, just the direction of it along the curvature makes a tremendous difference. So this is the first thing that you do have to realize about your edge flow and curvature when it comes to pinching is that direction is going to greatly affect this. So we'll go back to this clay-like material. This is what I actually like or prefer to do my 3D modeling. And we're just going to Control Z all this and get back to pretty much where we were. So I'm going to hit 1 to jump to my front view. I'll go ahead and drag marquee here when my face is selected. I'll do I to inset this. This is going to create what's called a boundary loop, and it's going to help to isolate this pocket of detail. Now we can do Alt E. This is going to bring up our extrude options and do extrude faces along normal, push along the normal. And now we have a corner here that we're going to need to reinforce. If we go back to object mode here, I'll do Control 2, just make sure that we have a sub D modifier. I'll right click the shade smooth. So you'll note that this corner is actually getting quite a bit of rounding, losing a lot of volume because we don't have the proper edge flow around it. So for that, what I'll do is disable my modifier within edit mode. We'll hit tab here to dive back into it. So I'll need a loop cut here. I'll do Control R, place it like this. And if you remember our first example, since this is running perpendicular to our curvature, we're not going to get any issues. Now we need a loop from this direction, right? And now this, even though we're reinforcing this corner properly, now we've added this additional edge loop that's running parallel. So if you could take a wild guess, if we hit tab, we go into object mode, we get a matte cap, we'll switch it back to that red material, and you see that we're getting some very pronounced pinching here. So how do we go about solving this? Well, the first component to this formula is getting the right edge flow. So for that, we'll dive back into edit mode, we'll switch back to this clay looking matte cap, and we'll do some basic rerouting to delete this edge and route it perpendicular to our cylinder, causing or minimizing the pinching. We'll select the edges that we don't need. So I'll select these and we can dissolve these edges. I'll select this vert here and this vert here. Since this is the last vert I selected, I'll hit M and then I'll select last, and you see that now these two verts are merged. So now what I can do is select this edge here and we could actually route it this way. So in this case, I'm going to select this corner here and this vert here. I'll hit J. And this is going to join and connect those two edges. And now I can select this edge, dissolve these edges, and now we're actually quadding out. So what I can do with this is actually select this loop. I'm actually not going to worry about anything past here, and you'll see why in a second, because I'm going to use a symmetry setup where we're only really modeling on a fourth of this. We can go ahead and just bump this up here. And lastly, now we have kind of this loose one here, and this also needs a partner. So I'll do Control R to add a edge loop. The problem is this is going all the way around. So there's a couple ways of stopping this. What I typically like to do is kind of set a stopper, meaning break up the quads and those loop cuts won't flow anymore. So I want to look pretty much around this symmetry line here, and I want to simply right click this, subdivide. What that's going to do is actually place this extra vert, which is going to break our quads, thus stopping this loop from going all the way around. Now it's going around this way as well, which we don't want to do. We could actually select this here, and this is another method, and we can hit V, right? And what V is going to do is actually rip this, meaning it's going to separate these components. So if I select these components, you see they're no longer attached. So now we have these components which are not attached, and this is going to stop the loop from going this way. And here we have this vert, which is another way of stopping, breaking the quad and not allowing this to flow. So now if I do Control R, this is going to kind of stay in the neighborhood that we wanted for all intents and purposes. So I'm going to drop this right about here. And then from this point, we can just select this. We'll hit J to join, and now we could basically select the extra fluff here, hit X, dissolve edges, and there we go. This is what I actually call a reroute pattern. Anytime that you have a pull, it indicates a change in direction. So essentially, I deleted this edge here, and this edge was running parallel to my curvature, and that was going to cause pinching, and I rerouted it with this reroute pattern to go perpendicular to my curvature and thus alleviating the pinching. So now it's time to actually mirror all the work that we did to each single corner. And for that, we're going to do some deletion and then use a mirror modifier. So I'll use the rip command again to basically carve out a fourth here. So what I'll do is I'll hit 1, make sure that I select this edge in the middle. And then I also want to select this edge here in the back, I can hit V here, and now this should be pretty much an island. If I hit L, this is pretty much polygonal island, so I can do Control I, that's going to select the inverse, hit X, and then we could delete these faces. And now we're left with a 4 for this. Before I do anything else, I can just take my knife tool, and since we want to constrain it to the X, I'll hit X, cut, and there we go. So now this is perfectly a 4th, and then we're going to use the mirror modifier to do the rest of the work. So I'll hit mirror. One's going to be in the X and one's going to be in the Z. And we also want to make sure that this is merged, which it is. We also need this mirror to be at the top and the sub D modifier at the bottom. Now we can hit tab to go to edit mode, and this is our shape. Now, this doesn't look that bad because this material has less specularity. Think about specularity as a way of exposing pinching or imperfections in a mesh. The higher the specularity, the more it's going to reveal any imperfections. For that, we'll go back and use our red material, and now you can see that our pinching is very noticeable. So at this point, if we switch this back, and what I'm going to do is actually turn on a wireframe. So now you might be wondering, well, GJL, we reinforced the corners properly, and we also routed the edge flow the right direction, perpendicular to this. Why are we still getting pinching? Level 2, density. The amount of density in your topology greatly affects the amount of pinching in your hard surface models. Now watch closely as we combine the correct edge flow with the proper density. It's a game changer for clean topology. First one is edge flow, which we have, but the second one is details dictate density. And we don't have enough density. So for a lack of a better words, this edge here or this detail really doesn't have a dancing partner to match to, right? If we were to go here, we really want to think about having an edge here and possibly an edge here as well in the base of our cylinder to have enough divisions to actually support this. While we have the right edge flow, we don't have the density. I'm going to switch back here to our red material, and this is pretty much our first example. We're going to label this E for edge flow. Let's look at the other example here. What if we took a cylinder that was really, really dense but didn't have edge flow? And for this, we're going to get our density times 4. So this cylinder, right, we started with 24. This actually has 96. Okay, so you can note here that we actually don't have any edge flow work at all. We just have a really dense cylinder that we punch this hole into. So if I go in here and remove this wireframe, you see that we actually don't get any pinching. Now, you might be wondering, well, why do I even have to worry about edge flow when I can model with super dense density? And this kind of negates the advantages of sub-D modeling, is having a low-res cage or a mid-res cage to be able to do your work, and then giving those extra subdivisions via the modifier to get a nice smooth mesh. So even though this is actually not pinching much, you probably wouldn't want to work with a base this dense. So let's look at what density and a little bit of edge flow looks like, right? So now we went from 24, this is 96, and now we're stepping back to 48. Okay, 48 divisions on this base cylinder. And what I essentially did with this is I did the inset, but we don't have those extra 2 edges coming in here to properly reinforce that corner. So how does this look? Again, if we disable the wireframe, you see that this looks a little bit better than this, right? And what I can actually do is move this over here and move this guy over here. So if we compare the surfaces, this one is relatively clean, no pinching. This corner is a little bit softer than this, right? Just slightly. Now, we are getting pinching here, and we're not getting any pinching here. So this is definitely a step in the right direction, but ultimately, we want to properly reinforce these corners with the same amount of divisions. And this is where the edge flow and density, so this is the best of both worlds, come into play here. And now we have 48 divisions, but we also have the proper topology to reinforce this corner. And this material might make it hard to see the edge flow. So here, if we switch back, we'll see that we have pretty much our edge flow properly routed and the right number of subdivisions. And now we'll see that we don't get any issues here. And if we go to our highly specular material, this is pretty much the optimal solve because we do have the edge flow correctly, the density correctly, but this is not so dense that we can't work and carve additional details. This last example here is something a bit more extreme in the other direction. So we have the right edge flow, but half of the density of this. So this cylinder started with 12 divisions versus 24. So 24 was already too light. And if we step back, you see that these edges here on that base cylinder, they have to stretch and work really, really hard to line back up. And this lack of density on that initial cylinder is causing a lot of pinching once we enable the sub D modifier. So if I disable here the wireframe, you can see that the pinching is the worst here because of our lack of density. Level 3, angles. Now that we've seen how edge flow and density can give us clean topology on straight lines, let's move to something more complex. Cuts at an angle. Curved, intricate designs often require angled cuts, and they bring their own set of challenges. Let's tackle those next. I'm going to illustrate this point.
They're coming straight in. Trust me, I've got nothing.
I am the
Drive them back!
They're pushing! Get out of there!
Cover!
I am the
About damn time.
Seriously? What's the move?
We killed them all.
You wanna fight and we happen to fight.
Go.
Some with this up, but you know I survived.
Where's the spike?
With a grid here, we're going to dive into edit mode with my knife tool. So this cut here is generating a mix of tries and also n-gons. And here, this cut, we are creating tries. Now we could actually manually try to clean this up, and keep this in mind when we are working on a curved surface. This is going to become a little bit more compounded as those initial cylindrical subdivisions have to be respected. Instead of doing time-consuming rerouting work, we could actually subdivide this one time, and all these tries and n-gons will actually revert to quad. So within object mode here, let me go ahead and just turn on my wireframe. I'll do Control 1 to add a level 1 subdivision modifier. And we simply want to bake this in, so I'll hit apply. So now we'll note that all those tries and n-gons actually became quads. Now, we do have the new problem of this actually not being straight, but this is an easy solve. We can simply delete this edge here by doing dissolve edges, and we can select these corner points here, hit J, and now we essentially have that pristine angled cut. And we also surrounded this cut with quads that are going to facilitate our clean sub D modeling. So let's put this into practice. I'm going to start here with a new cylinder, hit F9 to bring up the properties. And with this, I think I want to use 28 divisions. We're going to hit 1 here. And the first thing that I'll do is dive into edit mode, hit Control R to get some loop cuts. Again, we're going to create some squares. I think this number of divisions is fine with the loop cuts, and that was 9 loop cuts here. Now I'll get my knife tool and I want to create a cut. So I'll hit K. So I'll create this cut here. Before I do anything else, again, I will actually delete this cap for the time being. Object mode, Control 1 to add a sub D level 1 modifier. We'll go ahead and apply it to bake it in. Right click, shade smooth. And now if we view this, we're back to all quads, which is exactly what we want. Since this is going to be, again, pushed in, we want to create a pretty clean perimeter. So within edit mode, I'm just going to take this vert here and kind of start working these corners. What I want to get is a little bit more of a square corner here and a square corner here. So again, I can do edge slide if I want, but basically I'm trying to align and get this edge straight. Something else that I can do is basically select all these, do S, Z, and then this is going to scale flat in the Z and going to straighten out this edge. So now these edges look relatively straight when we apply this cut. Again, this area or this edge got messed up because of our smoothing. We can do dissolve edges, and then we could simply select these 2 points, hit J to join, and there we go. Now we do have a little bit of an issue, and I want to get a little bit more spacing. Anytime that you work with sub-D modeling, you want to let these surfaces breathe a little bit. So I'm trying to just let this breathe as much as it can. So I think this is going to work. And I'll hit 1 to go into the front view here, 3 to select my faces. But for this, I'm going to hit W 1 time. This is going to allow me to paint my selection. Sometimes, especially when you have these cuts, it actually tends to work. So we could just drag marquee wherever that cursor touches. It's going to be a selection. So I'm going to continue selecting here, and I'm holding down Shift because I want to add to that selection. And then again, Control to subtract from that selection. So now we see that we have kind of this inset, but we have this angle. So it makes it a little bit different than our initial examples. And now we're all nice and quiet. Again, I'll hit I here. This is going to create kind of that boundary loop. And this is going to help to isolate our detail, kind of route it in. And that boundary loop is going to support this mesh better without any pinching. So I want to be mindful of the spacing here. You see that if I go in too far, I'm starting to clamp. I could always readjust those verts, but I'm going to try to get this relatively clean without any clamping. I think this looks good. I'll do Alt-E, extrude faces along the normal, and then I'll simply push back. From this point, we'll go into object mode. We'll do Control-2, right-click, shade smooth, and then we'll disable the wireframe and see what we get. So overall, this is pretty good. We don't have any noticeable issues. If it looks like we get a little bit of pinching, it's probably because, again, of the spacing. We could dive back into edit mode, disable the modifier within edit mode, and simply just go back to our marquee tool here. So we should be able to select these. So we can dissolve these by hitting X. I'll take these extremes. I'll hit J. I'll hit K for my knife tool. Click this here. And now I can basically just slide this edge like this. Give this a little bit more breathing room. So now that we did some rerouting work here, I also want to add a bevel. It's going to help us reinforce this edge from the inside. So I'll select these edges here, and then I'll do Control B, add 2 divisions, and want to make sure my profile is set to flat here. I can hit P to change the profile on the fly. And if we take a look at the bevel, you see that the shape is pretty important because I don't want any angle. I want this to be a perfect 1. 2 segments. This is going to give me a segment on either side. And now if I hit tab, you see that we're getting actually pretty clean results here. So let's check our shading with something a little bit more extreme. And there we go, right? We're not getting any shading. We have pretty much our nice angle. And if we look at the wireframe, you see that we no longer have those tries or n-gons because we use that subdivision method to clean those up. Level 4, separate parts. Congratulations, you made it to the final level. Often, finer details like panel lines can introduce pinching when modeled as part of the same mesh. But here's where modeling in separate parts can make all the difference. Let's dive in. The first thing that we're going to do is actually figure out where our panel lines are going to go. So I selected all my panel lines here that I want. And one thing to note is if you were doing maybe like a bevel method where you create an inset and you kind of fake that panel line by just creating a small bevel inset and pushing that in, when you're going to reinforce these corners, because this is one fluid mesh, you're going to get that pinching again, right? To reinforce these corners as they flow parallel and perpendicular to the shape. So this is a good method if you want to essentially create panel lines that kind of flow into other shapes without having to flow extra topology, which could cause pinching on curved surfaces. So now that our panel lines are selected, we can hit V here, and this is going to rip or separate everything that was essentially outlined with those loops. So if we hit L on each of these, we see that they are separate shapes. So from this point, I can select one face, hit A for all, P, and then we could separate this by loose parts. And now these are all separate parts, which is exactly what we wanted. And what we want to do is actually add a solidify modifier. This is going to help us to get some thickness and ultimately allow us to create the hard edges that we want. I'll hit / to isolate this piece. I'll go to add modifiers, solidify, add this, make sure this is on the top. So we first want to give this some thickness here, like so. If the sub D modifier is a little too much, we could always disable that. Also turn on our wireframe, and since we're doing quite a bit of modeling work, I'm going to shift back to my gray material. This makes visibility a little bit easier. And now we can just set the thickness how we want it. I don't want this overly thick. I think this looks pretty good. The problem with this is that if we enable the sub D modifier, again, we're getting very loose edges. Now, there's a couple of ways we could do it, but since we are already working with the solidify, the fastest way is if we go under edge data here, we can simply toggle these sliders to 1, and we're going to get a hard crease exactly where we want it, which is these hard edges. If we go back to object mode, take this off, you see that we get a nice result. This looks good. Now we want to go back. I'll hit / again, and I'll select this mesh first, this mesh second, and I want this to receive this modifier here. We'll do Control L, we'll do copy modifiers, and what do you know? Now we have both of the modifiers here with the same exact settings. I'll do this one more time. So I'll select this piece here. This is going to receive the modifiers. This is going to give the modifiers. So Control L, copy modifiers, and there we go. I'll leave this 2 top pieces for the very end. Now I'm going to add some additional details here before I add my other modifiers. What I'll do is extrude these edges, and then I'll simply scale inward. I'll extrude one more time, push down like so. I'll do another extrusion. So we'll extrude these edges, and I'll repeat the process here. A little bit more detail, then I'll simply select this here, and I have grid fill already in my quick favorites. And want to align this here a little bit more with my symmetry lines. I'll play with the offset here. I'll go this way, and there we go. So grid fill did the job. Here I want to add a larger bevel, and we want to change the profile. So I'll hit P here like this, but I want to actually set this to 0.5. So what I'll do is I'll do Control B. I'll drop that, and we want 0.5. This is going to be a shape defining bevel. I want to drop this to 1 segment. And here with the sliders, we can get a shape that's more like this. So just a pocketed detail to make this a little bit more interesting. Something else that I might want to do is maybe bring this up. So I'll select one face here. We can do select coplanar. That should be under select similar. And we're going to do coplanar. Everything on this plane will get selected. So we'll do something like this. We could even grow our selection by doing Control plus. And I just want to make this detail less extreme. So I think this looks pretty good. From this point, I want to add some bevels. I'll select all the edges that need to be hardened. I'll do Control B, add another division, and make sure my shape is set to 1. And this looks pretty good. So now we'll go ahead and inherit the same modifiers. This will get selected first. This second, we'll do Control L. Copy modifiers, and now this took the same modifiers. And the last order of business is I'm not going to redo this, so we could simply add a mirror to this. I'll delete this. I'll go to 1 for the top view, and then I'll simply select this, add another modifier. This is going to be a mirror, and we need to mirror this in the Z. So we'll just hit Z, and we are pretty much done. So I'll go back to my material. We'll turn on cavity. I'll do Shift-Alt-Z. This is going to hide pretty much all my overlays. This looks pretty good. And now we'll do the final litmus test for any hard surface model. We will put this shiny red material. We'll check for pinching, and this actually looks pretty good. So let's view our final wireframe with a clean interface. So I'll hide the 4 axes, turn on the wireframe here, and this is what we got. So here we have our final result, clean topology with good shading. And now you're going to be able to create more complex hard surface models and more intricate details on curved surfaces without any pinching or shading issues within Blender. And that's a wrap. Congrats on improving your hard surface skills by mastering the 4 levels of topology for pro level 3D models without shading issues. Now I want to hear from you. What was your favorite tip that made everything click? Or did I miss any topology tips that should have been on this list? Drop them in the comments below. I'll read every one. If you're enjoying this video, smash that subscribe button so you don't miss out any more tips and tricks to level up your 3D modeling. I have a lot more content coming up that will help you improve faster and work smarter. Now that you master topology, improving both the quality and speed of your work is key. Luckily, Blender has some incredible free add-ons to boost your efficiency. Check out my video on the best free Blender 3D modeling add-ons right here.
How have you been?
Caught in orbit, spinning round. Every word you say just pulls me down. I'm holding on.
Have you ever spent hours trying to nail a hard surface pattern in Blender only to have it completely fall apart when you start to duplicate it and make it repeatable? Nothing's more frustrating than seeing all that effort and time go to waste when your pattern just doesn't align properly.
Oh, no.
But don't worry, I got you covered. Today I'm going to share my pro level workflows to break down and create any hard surface pattern in Blender. Whether it's a simple diamond pattern or an intricate weave, this process will ensure clean, repeatable patterns. No more wasted hours troubleshooting. Patterns are key on hard surface models. They're everywhere, from vehicle grills to fences on environments to even vents on mechanical characters. Mastering these skills will give you the confidence to tackle even the most complex 3D modeling projects. While I'll be using Blender, most of these workflows can be applied to other 3D softwares too. What's going on, you 3D modeling beasts? This is JL Musi. I'm a professional 3D artist with well over a decade of experience. I've created educational content for companies like Autodesk, and my 3D software reviews have been featured in PC Mag. Before we get started, I want to let you know that registrations are now open for the Hard Surface Masterclass. In this free training, we'll dive in even deeper into 3D modeling, and I'll walk you through my simple step-by-step process to create pro-level models that will help you land your dream 3D job. Join over 10,000 students who've already leveled up their skills in my previous classes. This is a limited time event, so don't miss out. Register now using the pinned comment down below. First on the list is the simple pattern. These are built off a grid and are the easiest to create as a seamless, repeatable pattern. This will set the foundation for more complex patterns, so follow along closely. I'll do Shift A, I'll get a mesh and a grid. For this, I want to add a grid with 20 divisions in the X. I like to be able to see my wireframe even from object mode. For that, we'll jump to the viewport overlays and I will enable my wireframe. I do have this set as a quick favorite as well, so this is a lifesaver as I can hit Q and toggle this on. From this point, I'll hit N to bring up my transforms. I want to make this 2 in the X. Since I doubled the amount of divisions on that grid and doubled the scale in the X, I have perfect squares. This is going to work out perfectly as I want to create a diamond pattern. I'll dive into edit mode. I'll select one face, hit A for all. I'll right click and I'll do poke faces. With these faces poked, it gives us the basis for a diamond pattern. Now, we do have to delete the straight edges, so I'll select one edge here, one edge here. We can go to select and similar, but this is a hotkey that's already native with Blender. So I'll do Shift G, it'll give me the same options, and then I'll simply select direction. And right now we have all the edges selected based on the direction that we want to delete. I'll hit X, dissolve edges, and now we have the basis of our grid pattern. I'm going to hit Shift D on this to duplicate this. And this first iteration is going to be wireframe. And then this second one, I'll simply call it detailed. I'll go to the wireframe option. Now Blender has a modifier that will look at your topology, and we can select wireframe, and that's pretty much it. Blender just took those edges and wrapped geometry around it. So if this is all that you need out of your diamond pattern, you would be essentially done. We can go in here and play with things like the offset, the thickness of this pattern. However, we don't really have the ability to create more complex meshes unless we apply the modifier. I'm going to call this iteration done. Let's work on a detailed mesh. For this, I'll dive into edit mode once more. I'll select one of these faces, hit A for all, and I want to do an inset. Now, by default, the inset's going to treat everything as one unit. What I'll need to do is just drop the inset, and we can go and select individual, and now we can basically adjust these individually and set the thickness. So I think this looks pretty good. I'll hit X, delete faces, 7 to go on the top. I'm not a fan of these border edges here created from that initial grid. I'll hit 3 to select my faces, and I'll pretty much drag marquee here. I'll do Control I to invert my selection, X, and delete these faces. Now we're left with a cleaner perimeter. From this point, let's add some thickness to this. We'll add a solidify modifier, offset the thickness.
Here we come. Keep them up, cause you ain't seen nothing yet. Wait till you see what we can do. Cause ain't nobody gonna give it to you like this, like this, like this.
And something with the thickness that we can do is under edge data, we could do a bevel convex. Any of these sub parameters that you don't know exactly what they do, what you can do is actually just hover over this field and they'll tell you exactly what we can do with it. If we want to bevel these edges, yes, we could manually do this, but we could actually use the edge data within the solidify modifier. I'll input 1. Nothing's going to happen because we'll need a bevel modifier. So I'll add the bevel, and what do you know? Now we have our bevel here. So we can play with the settings here. If we actually go to width, this actually gives us a pretty good result. And as a little bonus, we're actually all quadded. You can't always just manually select those border edges and add a manual bevel, but I think I'm pretty happy with what this gave me. So we'll call this pattern done, but let's actually give this some shape. If this was, for example, a grill on a vehicle, this would probably have a little bit of a curvature. To simulate that curvature, what I'll do is I'll get a UV sphere. I also will scale it in the Y just so it's not that round, and this will approximate pretty much the curvature of the front end of a vehicle. Maybe we could scale this up. We'll do Control 2 to add some more subdivisions, and we'll apply that. I'll take our simple pattern here and just rotate it 90 degrees. I hit Control A, we'll apply the rotations. That way we don't run into any issues on the next step. From here, what I'll do is I'll add a shrink wrap modifier, and we want to project this onto the Y, right? If we go here onto the right orthographic, you see that our Y is the axis that we want to project onto. So if we select the Y and now we look at our shrink wrap, it's properly applied. And the great thing about this, we can always hide the sphere here. And since this was done all with modifiers, we could always go back to our solidify, push and pull, as well as play with our bevel. If we wanted to change the bevels around, that's an option that we do have. And
So yeah, let's talk about topology in 3D modeling. And as you notice, this video is going to be a pretty long one. And it's also a direct continuation to the video just before this one. So where we talked about the benefits of creating or practicing simple pieces. And while that video was mainly narrative, here we're going to do the practical example based on that video. So again, the examples that you see here are very simplistic, but even that they are simple, you're going to see there's going to be a lot of things to talk about and still a lot of things to practice on. So the biggest question here before we actually continue is just make sure that you understand for what reason are you practicing topology and for what reason do you need it and where do you plan to use it. Because if you're working only in CAD and your final result is only a clean render, it's not going to be used anything else than a still image, then probably this topic is not interesting for you. Same thing is going to be if you're just working with booleans and your final image is a simple still render.
KiloCode is a powerful, open-source AI coding assistant that supercharges your development workflow right inside VS Code. But unlike other AI tools that just autocomplete what you're writing or create lines and lines of AI slop, KiloCode is a full development partner that can handle complex tasks across your entire codebase. At its core, KiloCode uses specialized modes to adapt to different development.
Then this topic again might not be useful for you. So, however, if you're planning to do 3D for anything outside of that, there's a good chance that whatever we cover in this video is going to be highly beneficial. Because even moving forward, so let's say that we now know for what reason are we practicing, but we still do not know the end results that we're going to create, being it, let's say, weapons, cars, vehicles in general, something that has, let's say, flat shapes versus something that has curved shapes. So if you're not sure in that yet, then in that case, we're going to practice both, because the true skill is then defined by your ability to use each approaches based on the situations that you're on. Because if you're, let's say, working only for hard surface, let's say weapon design, where you have mainly flat parts and not as many curved parts, you might then not practice so much, let's say, topology on a curvature, where then what happens is that you might assume that whatever, let's say, works for flat surface, that might assume this kind of like works the same on a curvature, while in reality there's slight difference in how we approach these two workflows. So till then, if you're unsure, then we're going to kind of like practice both. And the kind of like the core of the practice is going to be breaking the forms down to its simplest forms, and then we are building up. So we're building from the base up, kind of like from the simple to complex, because in the end, complex forms are just combination of those simple forms. And also a very, very important note here is if you notice yourself that you're struggling with the simple forms, the chances are that you're going to struggle that much more with the complex forms. So the biggest emphasis here is going to be on creating that strong core fundamentals on which you can build even more and more. And then later, once you have more, let's say, confidence, then you can just decide which approach to take, when and why. And it's just going to be kind of like easy sailing moving from there forward. So yeah, finally, even though that this video is too long, it's still a small part of our bigger topic, and I'm going to leave Topology Workshop link in the description down below. Check that out. There we're going to dig a little bit more deeper with additional examples. So yeah, feel free to check that out. So this kind of covers the intro, and let's begin. So now at the very start, the question opens in sense like, where do I actually begin? So how do I know where to create all these cuts, where to add all these loops? What exactly am I looking for, and why am I doing things that I'm doing? So why am I creating cuts there specifically, and why am I looking for these flows specifically that we're going to talk about now? So the same rule that we talked in a previous video, just in case you missed, I believe it's a very, very important video to check, and not as much as the video is actually what it's being talked there. And that is the power of simplicity, simplifying things, building bottom up, and starting from simple forms, progressing slower and slower into more complex forms. So regardless of how form may look complex, it's always built out of simple parts, and it always has sort of like the natural progression from its simple form to the complex form. So something that may have been a cube before, now it's something like this, but again, it started from the cube. So every single complex piece that we see, we are going to break down in the same sense. So if you're brand new to topology, kind of like if you're brand new to just kind of 3D modeling hard surface, and you would like to build your skill further, and you would like to understand actually why we're doing things and for what reason, what is the logic behind it and what is the thinking behind it, it really comes down to this: simplify the form whatever you can. So that means whenever you see a piece like this and you're not sure where to begin, simplify it whatever you can. That being either cut it down or start here. So whatever you do not understand, just cut it down to the basic form, because we still need to build bottom up. So for example, if I'm now brand new to 3D modeling, topology, whatever, and I'm not sure where to begin here, just start right here. So let me just create a duplicate for this. And let me extract this, and for now, delete this. Questions opens up. Are we able to create clean topology, solid topology only on this piece? If the answer proves to be yes, chances are that once we come to here, we may also solve this piece and this one and so forth. So if we stuck here, if I get stuck on this piece right here and I have no idea what I'm doing, the chances are that everything that I try to do after this, probably it's not going to end well. So what we're looking for here, when we have, let's say, a piece like this, that it's open up, it has no edges and whatnot. So why, let's say, purposefully would we even create something like this? Let's say that we created something in CAD, or we played with booleans, whatever, and now we need to retopologize this, create cleaner topology or whatever. Chances are we're going to get something like this. So maybe even we get something in terms like this. I don't know. So it can be something like this. So how do we know this is wrong? And so this comes kind of like all into play. First thing, what we're looking for are going to be the biggest quads. So whatever we can connect the point, we're always going to look for kind of like the biggest quads. So either being it here, doesn't matter, but the biggest quads and the dark quads are closed. Why quads? Because quads are always going to be predictable. So every direction that we just, let's say here, we keep adding, doesn't matter. You see that it's always maintaining the same structure, the same direction, and it's easy. If, for example, one of these quads forms a triangle, like here, now it's becoming less predictable. You see, now kind of like the edges flow everywhere, and those same edges are becoming a little bit more unbalanced. And what I mean by unbalanced is that the sizes of the polygons will vary drastically. So that means that whatever we are doing on one side to kind of like even out the form, that they kind of like become more and more same size, the more uneven they become on the other side. And again, that is not something that we are looking for. What we are looking for is grid. Take this as a general guide, kind of like visualize it in front of yourself and just try to kind of like wrap it around whatever you're trying to do. This is going to be kind of like the golden standard. This is the standard that we're aiming for. Sometimes it will happen, actually it will happen more than sometimes, that maybe we will have differences in, let's say, sizes that are going to be minimal. Minimal is fine as long as it's not double. So this is going to be kind of like our general goal and why we're doing that. So the question now opens up here. We have a situation where what to do with this? Where should we connect this and why? Why not here? And why here? And why not here? Or if here, why there? So if we are not sure, there's a golden rule: follow the outline. So whatever outline says, follow the outline. Create a fall off. So fall off as in sense of, if you throw a stone in water, that stone is going to create ripple effect around it. So the same thing, whatever you add here in between, let's say whatever edges are, doesn't matter. You're going to see also later. follow the outline that it's forming, so like a fall off. So if I show you what I mean there, I didn't want to do that. It's going to be right in the middle here, because if we are pretending, again, it's down in the water, the ripple effect is not going to be this, ripple effect is not going to be that. It's going to be kind of like balancing the sharp angle from the top and the flat angle from the bottom. So this will be kind of like that middle value. And basically that is how we know that we are creating that part here. So now when we have those big quads, we can now balance them. So again, this is now unbalanced mesh. This becomes balanced because the sizes are now more or less matching. But what about this? So is this good enough, or we need to balance that too? More or less, I would say, yeah, it's fine. You can leave it. If you can, let's say, if you're the good test is going to be to see if you continue adding. So if you continue adding topology, so is this looking balanced enough? So if the answer is yes, you can leave it. However, if you're not satisfied and you want to play around and see if you can balance it even more, maybe with 2 edges, play with that. So if this is now closely balanced, then we're gonna go with that. And then basically this is how you solve those unknowns. And if you're confident with this, and if you know how to solve this singular piece, again, the chances are that you're going to be able to solve this one too, and this one. So if you notice that, okay, so this is where I'm hitting a wall, try it a couple of times. Try it once, twice, 3 times. Doesn't matter. Try to explore every single variation that you get out of that. All this kind of like what we just covered, try to see how far you can get. So I'm going to leave this file as a download. Try playing around using kind of like this method, and yeah, just see how far you can come and where you're hitting the wall. So if everything goes well, you may come to this point, and then you might wonder, all right, so this one is a little bit more challenging than I thought, and I'm kind of like struggling a lot because I noticed that I'm encountering a problem, and that problem is, so let me continue. So let's say we are following the same.
Creators looking for an edge over the competition? Get 50% off and stand out with just a click. No mics, no retakes, just seamless, high-quality audio. So save 50% with 11 Labs and level up your game.
अरे कोई माचिस दो यार।
पापा।
हाँ।
ये किसका है?
जरा मुस्कुराइए, वाडीलाल खाइए।
वाह।
Approach where we are looking for those biggest quads. So let's say, I don't know, same thing that we had there. We're following here. So this will then go there because now we know. Here we can add loop. Let's continue looking for those biggest quads. So this one can connect here. This one again, same, connect here. This one can connect here. This one can go here, and then yeah, let's connect it here at the bottom. Yeah, here we have still on the top. Let's say this is going to be the biggest quad. Yeah, now we need to connect it here down, then it needs to go there. All right, so quads, everything seems to be more or less connected. It's still a little bit unbalanced because we do not have even sizes. And yeah, ideally we're looking for this kind of like that even size. So let's test it out. So if I'm start adding loops, okay, so this one will go there, then this one will continue here. Let's add this loop, let's add this one, let's add this one. All right, so slowly kind of like getting balanced. Let's add here, let's add there, and what the hell? Like, what is this? So this is the reason, because now the loop is actually, if I select this, you're gonna see where the loop flow actually is. So that's why we're getting this kind of problem. So when we see something like this, then we might go, all right, well, let me then try kind of like playing with these redirections, what we just talked before. Let's see what we get there. And yeah, let's continue here. And let's see how that feels. Okay, so now this loop actually continues there down. And let's continue kind of like balancing out. So we slowly may kind of like find a solution. And let's say that we want to balance this a little bit more. So we kind of like push this there. We add loop here. All right, so we balance this. We continue. All right, we can balance this maybe a little bit better. So let's continue this here, kind of like following the same rule of these kind of like triangles, where you're just kind of adding and balancing a bit, and kind of going in that sort of like direction, just kind of trying to slowly balance it out. However, what if even this is a little bit too challenging, or this is also proving to be more complex than we kind of like thought, because we are hitting a wall on almost every single piece here. And like here, I'm trying to balance this area, but this area right here kind of like unbalances itself. So what can I do then? So again, I'm going to create a simple duplicate here. Let's work on a duplicate. I'm going to show you one more example, which is an example of a cube. So every single design, everything in 3D that we do, we build bottom up. Same thing that we're practicing now, we're practicing bottom up. Same thing is going to be when we are building form. So we're going to build that form bottom up. So that means we're going to have more of a natural progression, where we're going to have already established topology. And then from that established topology, we are going to build further and further and further, establishing parts. And then we're going to build, let's say, on top of those parts further and further into details and so on. So the same thing is going to apply here. If we try to visualize, all right, so what I can do here to simplify this piece a little bit more, that I have less of a headaches and that I can get cleaner topology and then cut some parts out. So basically natural progression. So establishing a form first and then cut the parts out. So here then we can clearly see that this is the part that we would kind of like cut out. So that means that we would need to sort of like pretend as this piece does not exist and sort of like build it first without it. So that means again, let me deselect all of that, connect it here, delete, and this is now the piece that we're gonna have as a beginning, and then we're gonna build sort of like same thing as with cube, that clean topology, and then from that clean topology we're gonna cut this piece out. So again, now a new question opens up. How do we know how much topology we need? How do we know where that topology goes? And how do we know where to, let's say, stop in terms of density? So here's the deal. This right here is going to define what level of topology we're going to need at minimum. So when we're looking for which topology count we need to add, where the density is going to be, let's say, dense enough or not dense enough or not dense enough, this is going to be sort of like that benchmark. And how do we know that this is going to be the benchmark? Is because this is going to be the shortest distance between the two edges. So this right here. And if we know two distances, then we just need to balance that distance into kind of like parallel or more or less kind of like balanced form. And then you know, all right, so this is kind of like the density level that we're looking for. And this is the density level that we need to establish. And then we go from there. So adding one loop, and let's solve the quad. So you know what, just for simplicity's sake, I'm going to work without the bottom, because we can easily do that later. And let's just close kind of like, again, the same rule, those biggest quads. I'm going to turn the symmetry back on and connect this here and connect, I don't know, we can connect this here for now. and connect this here for now. And connect this here. And I believe that's more or less it. We're gonna see if we can kind of add some changes, but if we're getting full loops all across, that means that we have more or less quads established. If you notice, let me just move this around. If you notice that your loop is breaking somewhere, that means you still have an open area where quad is not solved. So now that we have a biggest quads, same thing in like with the cube, now it's going to be more, let's say it's going to be more convenient or easier to kind of like adjust or add topology on top and balance it further. And this is kind of like what we're looking for, that we simply can add topology without thinking too much where stuff connects, where stuff redirects and whatnot. So this is kind of like the thing that we are looking for. So once we have something like this, then we know it's going to be much easier to sort of like cut stuff out. And so another thing is here, as you notice, we may have, let's say, parts. So these parts right here are going to be easy to balance. These parts here may be less. So again, another question is what to do with these sort of like parts. So now we can play around a little bit more. We can sort of like afford that because the form is still sort of like in that simple state. So for example, we can play now with that redirection, kind of like to balance some parts out and just make sure, let's say, that we have decent enough topology. So you see here what's happening, that now this is breaking because we have this triangle established. So when in doubt, remove the triangle and then bring them back once you have more or less everything sort of like solved prior to it. And then you can add the triangle. Same thing is going to be now applied here. So if you have a big jump in polygons, you can connect maybe not this one, but this one I'm going to explain now why. Because if you open this triangle, then you have a possibility to add here the loop. And if we would connect it to, one too far. And if we would connect it here, then we would need to add a loop there. However, I'm going to show you something else. If we continue here, then these triangles right here, we can also solve by, let's say, adding so like this kind of like cut in the middle. However, please note that even if you leave the triangles here, it's not a huge deal breaker, because what is happening is that the only reason why the triangle is going to be sort of like an issue is in a sense that it's going to break your loop, so that your loop will not actually continue in a way maybe that you wanted to it. So even if you leave it as it is, it's not going to be a huge issue. So rule of thumb is going to be always kind of like observe the surface, especially if the surface is curved. And if you see a lot of deformations on a curved surface caused by triangles, then deal with triangles. Unless the triangles are causing no issues to the surface, you can leave them here as they are, as it is, without any problem. So that's going to be kind of like the general guide. For now, kind of like for our sort of like, let's say, sake, we'll just kind of, let's say, use this cut here and connect. Yeah, I want to leave that, and let's just connect this here, just kind of like to balance everything a little bit better. All right, so let's continue. A new question is that if I add this loop, what happens? I'm kind of like, again, unbalancing this. So what I can do is I can actually take this, slide this a little bit down. I can take this, slide this a little bit down. So this is now becoming that sort of like habit building, just cleaning stuff up. And why, for example, I'm moving this down. I wrote a complete article on this, which is called Understanding of Topology. It is on my website blog. I will not go now into this in great detail, but if you read, you're going to see why, for example, we can do that, and why, for example, even if I do this right here is going to be sort of like making sense, because just a quick example, let me show you here. It's basically the same if you would extrude this and you see in which direction this is flowing.
Infinix GT30 Pro 5G.
So the kids are alright. So the kids are alright. So the kids are alright. So the kids are alright.
Esports Ready Gaming Smartphone. Search on Flipkart.
আমি শুধু বলেছি 9 pieces for 299
9 pieces for 299.
রামমূর্তি ওরে 9 for 299
এ এত এক্সট্রা কেন ব্রো?
কারণ এক্সট্রা চিকেন আছে ব্রো। KFC Epic Savers 9 piece পান 299 এ।
সরি গাইস, ডিলস চলছে ইনসাইড।
So it's not actually flat like this. It actually has sort of like a little angle to it. So for that reason, when we kind of like balancing the topology, we can sort of like balance it in that terms that we're kind of like pushing it a little bit more around and sort of like balancing it a little bit more. So that's kind of like overall reason. And then the same thing will apply here. Instead of 3 loops, I don't know, we can just continue, maybe add 4, doesn't matter. But now we have established so like that general distance, and it's all about the habit building. Kind of like if you learn to clean your topology on one side, you will just kind of like next time you will not even think about that. So that's kind of going to be the main thing here to remember. Just kind of like cleaning it up a little bit and balancing it, and always looking for whatever you can do to clean it up. And more or less, let's say that there we go. So now the issue is, what about this right here? So what about that? Let's undo all of this, and let's try to add, let's say 4 edge loops. So here more or less we're getting kind of like everything evened out. Here we're getting everything evened out. Now here, here's the deal. So what to do with this? Because this is now already a double, kind of like the double difference in topology. So the really important thing to remember here is, what do we plan to do next? So do we plan to kind of like subdivide this further and further and further? If so, this may become sort of a problem. However, is it going to be better if, for example, so now I'm going to kind of like destroy this, what we built there. If we leave it like this, this is balanced, this is balanced, this becomes unbalanced. So that kind of like means that this area, since this area is so problematic, we should kind of like address this area where we are leaving everything else as is, and sort of like balance this one maybe a little bit better. Let's say redirect it, so to say, here in a way, and that we get kind of like this even topology back, where now again we are getting a triangle. Now the new question opens up, is this new triangle really worth it? Because let's say then we would need to add a new edge loop. So now it's good to know all these things, you know, what to do next and what is being worth over the other. So the question for us is now the thing that we balancing here out more worth than to keep more or less here the structure intact, and that we actually have a proper flow around. So for now, we're going to be satisfied, let's say, with whatever we established here as it is, and call it, let's say, this is now completed. One more thing that it's missing though, we're going to do a duplicate here before we continue. One thing that it's missing here are support loops. Support loops that actually emphasize the highlights of the holding corners, which is going to be everything here. So all of this. So this one, this one, this one, this one, and I'm going to select only these. So more or less, these are going to be general highlights. And all right, so this happens, I don't know, I've seen this plenty of times, kind of like asking in my Discord, I don't know what that is. Just kind of like delete it, and there you go. So now we're gonna have a clean established topology with holding corners, and this would be sort of like the ideal topology that we would use always before kind of like moving into kind of like deeper detail, and so on. So this is going to be the base that we are going to build on top. All right, so here I actually did not connect this, I forgot, and that's kind of like the back, and we're going to do the same thing, kind of like push this, but it doesn't really matter because now we know why we're doing this. But overall, this is going to be kind of like that beginning for this, because from here we are going to now cut out the part from the top. Let's do a small test to just see if we have this area right here established. So do we have that topology count? And if we compare this one to whatever we have here, so the minimum is sort of like already established. So the minimum kind of like flow is already there. Before we continue, I just want to do one thing, and I just want to explain also one kind of like the final note here, that technically, let me just show you something. If you do this, it's not wrong. So even if we leave the triangle here, it's not a huge deal. So it's not a big deal breaker. The only time it is going to be a deal breaker is if we now need a loop and the loop is being broken by the triangle. Second time where it may be a deal breaker is if this is a curved surface and this specific triangle right here is causing the curvature to bend wrongly or causing some kind of like weird deformation. Only in that case we are going to address. But let's say if we are now really kind of like looking for that edge distribution that sort of like helps us a little bit better, price of a triangle, it's not big deal. So even then we can do that. So we do have, let's say, a little bit more organized topology. We do have a little bit more cleaner. The only price, so like we're paying for that, is kind of like organizing the topology with triangles. So we don't really need now kind of like add a new loop here to kind of like even it out into a quad. It's not necessary, because if we follow the rule, observe the surface, and we do that. So observe the surface. I'm going to add here my kind of like the metallic material. Surface is holding just fine. So we don't really need to kind of like address this triangle in any kind of like special way. So if we compare now the two, which one is cleaner? Obviously, this one is looking a little bit cleaner because we do have that even distribution of edges here. This distribution is a little bit unbalanced, and the only thing we did is just kind of like switch it here into a triangle. So it's kind of like definitely a good idea to play variations. So I just want to, before we continue, I just want to address one kind of like thing that I'm pretty sure that it's going to be mentioned in the comments, because I noticed it almost in every comment section, and that is, dude, why bother? So why bother doing all this stuff when you can just kind of connect edges like this, and in the same sense everything is going to hold. So we will not kind of like have any kind of like problems, any issues. We're gonna get almost the same result as, where is this? We're gonna have almost the same result as we have here, and there's no need for all this kind of like topology stuff. There's no need for topology explanations. You're overcomplicating it. We're overcomplicating it, and it's just like doesn't make sense. Just do it like that. So here's a huge kind of like factor why this matters. The moment when we come to curved surface, all of this here that we applied is irrelevant, because the moment where this becomes a curved surface, or the moment where this approach from the bottom, this right here, when you take in the same approach on a curved surface, there's going to be a lot of issues with establishing proper topology, or establishing proper curvature, or establishing, let's say, connections that actually hold and are maintained on a smooth surface without any deformations or any issues. And this is kind of like the thing, what is going to be the biggest factor of it all: habit building and know the purpose. So habit building means that whatever you want to do, you need to start doing it somewhere. So you need to practice it somewhere. So whatever you practice, so if you're common in thinking, well, I'm just going to use sort of like this approach everywhere, eventually you're going to hit a wall, and you're not going to know why you hit a wall and for what reason, because what you were working on a flat surface worked well so far, but the moment you come to the kind of like curvatures, like automotive design styles, you're going to hit a huge wall and you're not sure why you're hitting that wall. You're going to see a lot of pinching, you're not sure why pinching is there, because the rules that are established on a flat surface are not going to be sometimes the same that work for curved surfaces. Second thing, what I mentioned besides habit building is know the purpose. So for what purpose do we practice topology? Where we want to use it?
How have you been? Caught in orbit, spinning round. Every word you say just pulls me down. I'm holding on.
With Google Workspace, you can create a Gmail account with your own domain and branding, helping your business look professional in any inbox. That's business email made easy with Google Workspace.
And where it's actually going to be useful for us. Do we want to work as a hard surface weapon artist or just hard surface vehicle artist? It doesn't really matter. The matter is know the purpose and know for which purpose you're practicing topology, for which purpose you need the topology. Are you working only specifically on low poly models, or are you planning to work on high poly models? So is something that you're working on going to be a hero asset that is going to be close to the camera, that is going to require a lot of detail, a lot of precision, that is going to require almost non-visible pinching, where the standard is going to be so high that you're going to need to have almost everything in even size quads, where some companies or some studios would definitely require that. Some clients I worked for, they were specific about like the cleanliness of the topology, which was requiring a lot of different approaches to kind of like achieve those results. So once you know, once you have a clear goal in what you're trying to achieve and for one purpose, then you're going to build skills around that. So whenever you hear why bother, you should be aware to know why exactly are you bothering and for what reason. Because if you don't, then it may happen that what you're working on right now or what you're practicing right now is actually irrelevant for what you want to do. So just be clear and be very, very clear for what purpose are you actually practicing topology, and in which direction do you want to take your skill and for what reason. So just want to address that because it was a very, very repeating question. All right, so moving on. Now when we have established topology, now when we have established, let's say, base, now we can start cutting pieces out. And this is going to be considered as a primary form. So whatever you hear in 3D modeling, whenever we're establishing something, whenever we're establishing an idea or you're working from a reference, you're always going to look for this. So if you see in a reference something like so, presented here, this is your reference, you are probably going to build it like this. Even if you start building with booleans, be sure to understand what type of topology you need there to come to this point. But in case you're struggling with that, this is going to be approach, building it from the bottom up, coming here and then cutting pieces out, which again, this right here is going to be secondary form. So primary form is established, now comes the secondary form, and now we are cutting those parts out. So if we want to be extremely precise, what we are going to do, we're going to kind of like remove some parts here. And this is now what I just want to address one more thing before we do. This is now that fall off, what we talked before. You have one edge and you have a second edge flow, and everything in the middle is going to balance itself based on what you have established kind of like here in these edges. So you see how edges are slowly kind of like adapting to whatever distance they're closer to. So just something to keep in mind. All right, so let me just isolate these two and let's slide this into position. And if we want to be super precise, I can just select my snapping point. The hotkey for that is V, and it's going to be found here. You're going to see hitting V, it's snapping. And just as you're moving it, decide or hover over the point, whatever you want to snap it to. So let's say this is the point where we are snapping it to, and then we're just going to add, let's say, more cuts here and just kind of like balance that area out. All right, so now we're going to continue, and the thing is we are going to need to then create a cut, let's say from here. Let me just isolate this from here. So here from this place. So here to here. And so before we actually cut that out, let's do a small offset, because what we are doing here is we are creating a support loop. Because if we are just cut it here around, then that means that here around it, we will going to need to have a support loop, and then kind of like everything changes a little bit because you need to go all the way around. But if we do it like this, then the job is already kind of like done for us. One small note when doing extrudes in Maya, and that is when you're doing the extrude and do nothing. So let me just show you real quick. So let's say I want to extrude this and I do nothing and hit Q to confirm. It seems as there is no extrusion, but if we subdivide preview this, you're going to see that we have a double edge, this edge and this edge right here. So where that may become an issue is when you're adding loops and you see something like this. Like the loop looks very clear where it's going to go, but it suddenly stops. And if you're wondering what is going on, why my mesh is looking like this, chances are you have your double extrusion there. So whenever you're using extrusion, you just make sure that you actually create an extrusion from that. And yeah, there we go. So now we have this, and then we can delete that. And yeah, so now we have an opening for this piece right here. So the only question is this opening, it has here a flat area. And in order to do that flat area, first we need to connect something. So let's bridge this. And then once we bridge that, let's add a cut here. And same thing, I'm going to use the snapping tool, which is going to be V. As I'm moving, I'm going to snap this to this edge right here. So now I hit sort of like the major, kind of like the curvature, which is this one. So just to repeat, we're going to take this, hold V, and then snap it here to any point where you want to have this edge snap to. So now when we have that, let's find where this edge actually is. So I'm going to again select it, move, hold V, and as I'm moving, I'm going to point the cursor to here, and then I'm actually matching the point where that is. And now we have this opening. And the only thing now that we need to do is we need to fill hole. And yeah, now we just need to select connect all these pieces together. So I'm going to connect this here, and I'm going to connect this here to clean it up. And here we have 3 edges. So let's add, actually, no, we have, 3 edges. And this one goes here. This is going to be quad. This one goes here. This one goes there. And then we have an issue where this edge goes on the inside and it does not have any connection. So it does not lead anywhere. And typically where it does not lead anywhere, you really don't want to make it lead anywhere, because what we are now doing, if we would do that, we are creating the balance. Actually, we are creating the unbalance into the balance mesh. So instead, for now, let's leave it where it is. We're gonna deal with it a little bit later, because what we still need here is this issue right here. So what to do with that? And the issue here is that we need a support loop around it, same way that we did here. So we have kind of like the main loops here, but we do not have a loop that needs to come, okay, that needs to come here on the inside. So we need to solve that first. So the thing is, here, there are a couple of ways you can do this. One way could be maybe easier if you do not want to do it manually, that you actually select everything and do small extrusion on the inside like this. It's going to be much easier just in case you're brand new, and if you don't want to do kind of like manual, this is how you're going to do kind of like that inner extrusion. If you need to go manual, then the only thing what it's going to be is that we actually need to connect all the points by following the outer edge. That is one edge loop or one support loop. This is the second, and again connects here, and so how do we know exactly that this connects here? This, like, how do we know this? I'm going to show you real soon. Let me just finish this, and we're going to connect. All right, so yeah, let's discuss this. So how do we know? For example, this is pretty easy because again we need to kind of like adjust loops, but how do we know that, for example, this one goes here and not, let's say, here? If you're not sure, always take a cube. Take a cube and select every single edge bevel. All right, so let me actually make sure that the camera-based selection is on. All right, so here by accident, I now changed the background. So let me address that. I think it was, I'm not sure, 22 was not, 25, 26, 27. I don't know, let's say 27. I will need to reset that. So yeah, what I was saying, yeah, select everything. By the way, Alt B is the hotkey for that background, and Control B is what I was looking for. So we have this right here. This is the cube. This is the bevel. What happens is when we offset this, you're gonna see what we are getting here. There is a video on my YouTube channel called Understanding of Support Loops, or Importance of Support Loops and Importance of Edge Flow. I would highly recommend checking those because I will not go into extreme now details why this is happening and how this works. So if you wish, the video is called Importance of Support Loops, Importance of Edge Flow. It is in combination with the project that I did Also here for YouTube, it's going to be a small project, and it's kind of like Mortal Kombat masks and whatnot. You're going to see it. It's going to be very hard to miss. So it's basically that what we are trying to achieve here. So that's why we know that this goes in this direction. So what to do now with this right here? So if not sure, just connect it to the next neighboring thing or the next neighboring edge, you know, go that far. So in our case, we're going to do this. Next neighboring edge, we know is going to be this. So what to do after that? So now the question opens up, where do we connect this? Do we connect this here? Do we connect this there? It's actually much more simpler than that. And the connection actually goes, let me show you even clearer. Come here, combine it all together, and I'm not sure if you notice this. If you delete it, you get exactly the same example what we talked now about the cube. So this is how we're going to connect these edges. And same thing we're going to do here. So we're going to connect this here, delete it, and we get sort of like this support loop connection. Again, I will not go into great detail about why this is, because there is a dedicated video just for that. So if you want to, it's called, again, Importance of Support Loops, Importance of Edge Flow. And in addition, feel free to check the simplified topology video. Also a lot of stuff we discussed there. So basically what we did here is exactly the same thing what we have here. So if you just kind of like look at it on the weird angle, you're going to see that it's exactly the same thing. And that is how we solve that part. So we have few more things to solve here though. And that is what to do with this edge. And also, isn't this edge or this surface sharp here down? So we have everything is sharpened up except this part. So we need to kind of like deal with that. And here's the deal. So we need to sharpen this one, and we need to sharpen this one. And before we do that, let's think what we can do with this. So in our case, we cannot do really not much except close it into a triangle either here, or just continue and close it here. This is kind of like the only thing that we can actually do without imbalancing the complete project. So yeah, just leave it like that. And if we follow that rule, which is observe the surface, let's add shiny material and see if the surface is holding okay, triangle can stay. Doesn't really matter. So let's leave it like that. All right, continuing forward. Next thing, we need to sharpen this one. So let's just do that. I'm gonna add a bevel, sharpen it, and there we go. So now I have my sharp edge there. The only problem now, what we did is this part right here. We need to deal with that. And in order to deal with that, I'm just gonna create one more extrusion here, because this is actually the support loop for the bottom that we cut out. So if we would have a bottom, this would be a support loop. And now what we need to do is we need to simply deal with this area right here. And this is going to be our select typical redirection. This is very common, and probably already you know this, but just in case you don't, we're going to have two versions of an edge. This is going to be one version of an edge, and this right here is going to be a second version of an edge. And this second version of an edge is going to be called redirected edge or redirected. And redirected simply means that the loop that flows here, we actually want that it flows here up. So this is what we need, and this is what we are getting. So this is what we're getting, and this is what we need. So in that sense, this is why we call this redirected edge. And because again, the flow now goes to the top instead of a straight line. And basically now we need to create this out of this area right here. And it's basically showing us that it's already ready to do that if we remove these three edges. So the kind of like solution already proposes itself to us. And the solution is, if you would split to this point, so this edge that we split it here, and this edge that we split on top. Just pretend they are kind of like split and kind of like pushed on the side and following into that point. So there you go. The kind of like solution already presented to itself. And the only thing that we need to do is connect this into a quad here. And there is your kind of like redirected edge. And the same thing we need to do on the other side too. So just delete this and make your life easier. Pretend like you're sliding this edge here, making this one void, sliding this one here, making this one gone. And then in the end, just kind of like snap it to here. And there we go. And this is now a project completed. So we have this as a base, and this we have as a cleaned up mesh. One thing that it's here left, and that is that this also needs to be sharpened up. So let's sharpen it up too. And let's just connect this in the same way we connected the top. And there we go. So now we have this piece that was originally kind of like just an idea or Boolean or CAD. Now we have a proper topology for that, and we kind of can call this finished. Another point I want to make, and that point is why bother with kind of clean topology? Why bother making sure every single edge loop is evenly distanced here? Because if it's not, you would get this. You would get this extreme kind of like stretching here on this side again, and unbalanced mesh, which again, it's going to be kind of like important to build sort of like those habits that you want to actually have later, because what we practice here on a flat surface, it's much easier than what we're going to do on a curved surface, because flat surface is more forgiving. So anything that we do on a flat surface, it's going to be not as visible. Or even if we do some mistakes, or even if we do kind of like topology that it's maybe not ideal, it's still going to be more forgiving, because again, it's not as visible. But yeah, so again, just be aware of the purpose of the objects you're creating, and be aware of the purpose why you're actually practicing topology and what goal you're trying to achieve with it. So what areas of expertise are you actually pursuing? So be very, very clear about that. So now new question may pop up, and that question is this topology right here dense enough, not dense enough? And how do I know if my topology is dense enough, needs to be less dense or more dense? Again, I'm going to redirect you to the video that I did not long ago. It's going to be called The Importance of Subdivision, or Adding Density or Removing Density, Importance of Density Overall. Feel free to check that out too. We go there a little bit more in detail. I will just cover this also very, very shortly. And as long as you have enough edges to hold the general...
Creators looking for an edge over the competition? Get 50% off and stand out with just a click. No mics, no retakes, just seamless, high-quality audio. So save 50% with 11 Labs and level up your game.
दो को 50
मैं दिया 100
all low, they are all low.
One enemy.
Whoa!
Form, that is going to be enough. But the rule of thumb, we're going to increase the topology only if we plan to use it. Otherwise, it's not necessary. So I've seen also this a lot. So smoothing it out, and basically this topology level is not really contributing to anything, and it's just there for no reason. However, if we have a reason for it, and if we have a purpose for it, then it's actually, again, purposeful. So that means if I plan to do additional detailing here, if I plan to, let's say, create here, I don't know, extrusions or cutouts, then we are going to use that topology. So we'll, let's say, straighten this one and straighten this one and kind of like extrude in to create, let's say, I don't know, specific detail, or let's say here at the bottom, you know, kind of like create specific looking details. Now this topology becomes purposeful. So it has its purpose, it has its use, and we are actually using it, contributing, moving forward. But if we do not plan to do that, and if we are kind of like using shape only as for the sake of creating the shape, then the topology that it's used to hold the main forms, that is going to be the topology that kind of is going to be the final one. So yeah, more or less, that will be kind of it. Let's now continue and see how rules are going to change if we have a little bit more of a different type of surface, which is going to be a curved surface. Now we're going to talk about cylinders and curved surfaces. So everything that we discussed in the previous example, it's just going to continue here. And you're going to notice that a lot of the rules that we established for the curved, for the flat surface is going to be applied for the curved surface as well. So those rules are going to be kind of like establishing the biggest quads first, looking for those even quads, whatever possible, and also building from simple forms to the complex forms. So even though, let's say that in this case, we know what the end form is going to look like, we still can break it down to that simplest form. So if that simplest form is going to be just a cylindrical form on its own, we need to see how do we actually come from the cylindrical form to this one right here. So it's not really the same as we had the previous example where we can just simply build on top, especially in the cylinder. And if we're using Boolean, we cannot use that, because with the cylinders, we need to have a little bit more strategic approach where we need to just make sure that all these kind of like parts match. That if we are creating, let's say, a cutout like this, that it's actually matching to the cylindrical part, because if it's not matching, we cannot move cylindrical parts like this, that we just attach them wherever we want to, because otherwise we are kind of destroying the cylindrical curvature. Also, one very important factor when working with cylinders is going to be adding and removing select edges, because with the cylinder, let me just quickly show you what I mean. With the cylinder, we can add horizontal edges the way we want to, but the vertical edges we cannot. So we cannot just add edges like that. And to see it a little bit more clear, I'm going to apply a single material, turn the minimalness all the way up, and see by roughness. So you're going to see the difference. So this is a cylinder where we did not add edges, and this is a side where we did. So basically what we did is just destroyed the structure of the cylinder with these new edges, and we cannot manipulate cylindrical surfaces in the same manner. So the approach is going to be very much different in that sense. If we are thinking of a simple cube, and again, I would refer here the video that I did a while back, which is the importance of subdivision or controlling the density of the mesh. If we want to maintain the curvature, the edges around the curvature are going to establish the level of curvature we need. So for example, without these edges, we get curved surface. And with these edges, we get stronger kind of like edge. So stronger, let's say stronger curvature, less stronger curvature. So manipulating that is going to be important in how the curvature performs. Based on the level of the curve, we are going to need to balance the remaining of the topology. So that means if something can go, it can go, as long as the surface is intact. But the moment when we adjust the corner, remember that balance, we need to balance everything everywhere equally. So that is going to be kind of like the main point of it all. However, if we would like to maintain the curvature and have more topology to it, the only way we can increase it is by smoothing it and subdividing it. So further and further, depending on the level of detail that we plan to build on top. And the level of detail, again, is going to be defined right here. So if we plan to go that far, then that means that this is going to be sort of like that, the curvature that we're establishing, the topology that we need, and from there we're going to cut our parts out. So another following very, very important topic is going to be, let me just create here a small situation. The corners. The corners are going to be again in the two main categories, and that is going to be redirected and not non-redirected corner. So these type of corners are going to work a little bit more different on a curvature than on a flat surface, because on a curvature, these kind of like redirected corner can cause slight pinching. So it's going to be extremely important factor which purpose the object is being used for. So if you do not know the purpose, you practice both. Make sure to understand both well. If you do know the purpose, then doesn't really matter. Whichever you choose is going to fit to the purpose. For example, if this right here is a background object somewhere here in your scene, it doesn't really matter. You can leave it as it is. You're not losing anything. However, if this what you're creating is going to be full-blown in your face or in camera, like full-blown in camera hero asset, then matters a lot what type of approaches do you take. So in that case, I always suggest practice both, make sure to understand both. That way you can switch between each situation seamlessly without thinking too much. All right, so this I know, I'm gonna do only these type of models, these type of, I don't know, props or these type of objects because I'm not comfortable in this. So find where you're not comfortable with, understand why you're not comfortable with creating those things, isolate the beginning of those a bit more. So we kind of like push this there, we add loop here. All right. What is going on, guys? My name is Mario and welcome back. So in today's video, we're going to talk about stagnation in our learning progress. Now, when I mean stagnation, I mean kind of like losing the sense of direction in, let's say, creating anything on your own. So if you're, let's say, starting a project, you're probably sometimes not sure how to actually start it, you're not sure what's happening in the middle, and you're not sure how to bring, let's say, project from the beginning till the end. So even if you're, let's say, following a lot of tutorials and following, let's say, a lot of courses, maybe you're missing a factor. Even though that you understand information, you're lacking, let's say, that aspect, how to actually put that information in a practical sense that you can see benefits from that. So in this video, we're going to talk about establishing exactly, let's say, those metrics or baselines that you can isolate, let's say, a part or find a gap. What exactly is slowing you down? Focus only on that part that is slowing you down before moving, let's say, on to the next challenging part. And then, of course, slowly we are going to increase those levels. But yeah, the topic of this video is going to be exactly that, kind of like establishing the baseline, finding the gap in the knowledge from very, very basic, let's say, examples, and then slowly building it up and just finding the gaps, addressing the gaps, and then combining the parts together. That obviously in the end needs to be combined. So yeah, that is going to be a topic of this video, so let's get into that. All right, so before we begin, I just want to share a reference first. So this is going to be, let's say, our guide on some specific parts, and just to kind of like illustrate a point or illustrate, let's say, part of the presentation that I want to talk about here. So first things first, before creating any object, we need to be sure in one thing, and that is the purpose and the use of that object, because based on that information, the approaches are going to change. So in this case, for example, we are going to do a couple of approaches, and the reason why I would recommend this sort of like exercise is that you're not in this way only limiting yourself to one approach. And that just means, let's say, when the situation comes to create something on your own, you only know one method. The goal is actually that you explore all methods, all variations, all, let's say, edge flows, all density options. So when the time comes, you're ready to evaluate on the spot with which method you're going to use, which techniques is going to be, let's say, most beneficial, optimal balance for the results that you're trying to get. You are optimizing your workflow for maximum efficiency, that you can actually create objects in, let's say, highest quality but with minimal time investment. So here the next thing is going to be, we're going to talk about at the very beginning here about blockouts. Now personally, I believe that blockouts is very, very underrated, and I know that there's a lot of techniques which can utilize, let's say, basic blockout and directly starting into, let's say, adding topology, adding density, adding support loops, details and whatnot. But there's a power in a blockout, either, let's say, if you're creating your own work, or if you're, let's say, recreating something per reference. And now, as an example, just what you see here on the screen are two parts of, let's say, the same reference. One part is going to have a sharp corner here. The second part is going to have more of a softer corner here. If we observe the reference, one of these two examples is going to be closer than the other, and this is the one on the right. So the reason why would you do this, why would you create, let's say, this edges right here as opposed to only, let's say, a straight edge here, is that along the way, especially if you're just starting out, you can actually visualize, remember, and be cautious of, or be vigilant, let's say, about the work that it's ahead of you. So if you do not do this, what can happen, and this is something that we talked about in 2 videos before, where topology is actually overshadowing your art, and this is also a real-time example that I've saw, and that is, if you're, let's say, not careful, what can happen is that you're just working along and you see an edge and you immediately let's say, think, all right, so this edge needs a support loop, and you get a sharper edge just because you're, let's say, lost track of the reference, lost track of the guides, and you're just following those topology rules. If you go a little bit further and just create yourself a little bit more like kind of like training wheels or idea, at least you're going to be aware of the softness of the corners that are going to be implemented later. And if you have that, the chances are once the time comes that you're fixing the topology, you're also going to be aware that this corner also needs to be fixed accordingly. It needs to have proper flow. It needs to have, let's say, proper edge loops density in order to get the softness of the corner. So that is one thing. So to see, let's say, a little bit more of a practical sense, I can also show you this on another example where, let's say, if you're creating, again, your own designs, or if you're following a reference, and this is going to be especially important for, let's say, mechanical parts, that you can sort of like sketch your, let's say, path a little bit more clearly on what is there to do. So this is going to be, let's say, an approach where you don't really have to think about, let's say, what the topology is going to be, but instead you're focused purely on the form itself. So as an example, we're going to have here a cylinder, and I don't really care, does it have, let's say, support loops, or does it have even spread here? This is not the case. The only thing that I'm interested here is to create, let's say, any sort of idea for the design that I like to have. So if that is going to be, let's say, something like this, then I'm going to just push it forward. And let's say push this forward. And then, for example, we can use here Boolean on this, and we can also use Boolean on this, and just establish a quick form. So let's say something like this here, push to the side, and there we go. So let's say I'm satisfied with this. What if I want to play up, let's say, the variations, and I want to see how, for example, this design would look like if I would have, I don't know, beveled edge here, or even before that beveled edge. What about adding bevel here, attaching the segments there, and then let's say create a bevel here, and then I have that, and then I have another bevel here, and then I have this hydraulic design. Now this is already a start for something. So if I would just jump directly into the topology work and just having this thing on my mind without actually kind of setting the idea first and directly, let's say, the idea out of my mind, that we now strictly and directly go immediately into that topology development. This did not take that long. And the same thing is going to be if you, let's say, working on something a little bit more complicated. You're going to have much more benefits, let's say, setting something like this for yourself first, just to visualize the road that you need to go to. Because again, if you do not have this and you jump directly into topology, then that means that a lot of unknowns you're going to need to solve along the way. And especially if you're a beginner, you're just kind of like, I don't know, cornering yourself in that aspect. So that is going to be one issue with the blockouts. Now, the second thing that I would like to discuss here is that even if, let's say, you did this, now a new thing can open up, or let's say a new practice can open up, just in case you're not sure how to proceed forward. Because even if you, let's say, have a blockout like this, or even simplistic version like this, now the question is, all right, so do you actually know how to approach this with a proper topology? So the small test usually that I like to give here is going to be based on simplifying everything to its smallest parts. So the question is, if you would work only on this piece right here, would you be able to, let's say, solve the topology that it's around this piece without any, let's say, too much thinking on what to do? So how to connect it, where to redirect what density level do you need, what corners need to be sharpened, what not. So what is the level of understanding here? Now, why did I isolate this piece? Because this is going to be your baseline. So this is going to be kind of like your metric or benchmark on how you will do everything after this. If you struggle here, the chances are you're going to struggle here as well, and especially here. So good practice would be making sure that first your base is strong. So let me just here clean this up a little bit. And what I mean is your base strong, I mean how effortlessly can you actually solve the topology parts here, maintaining, let's say, either natural flow, natural directions, and also how far can you go in, let's say, finding different variations of this object. So let's say this is a variation with natural flow. This is now going to be a variation with slightly more density. So let's, I don't know, go this route where density is holding the corner. Then let's go to redirected corners. So what we can do is we can redirect this one here. So this one can be redirected. Then we have the one here on the top that usually also can be redirected. And we are just missing here a loop. And here we cannot do much else except maybe this one slightly push down, and then these 2 points are going to hold this corner, and that is the maximum that we can do in this case. So yeah, moving forward, what else we can do? So okay, this was actually the first one. We're gonna need to have this one here. And let's kind of like strip this off. All right, so now we have it again stripped. So what else we can do? We can, I don't know, change the flow a little bit differently here now. So it can go like this. And then we have this approach. I don't know, so something like that. So again, why would you do this? Because again, you are testing your, let's say, skill level on how flexible are you when the situation comes that you can adapt to the situation that it's necessary. Usually I would get a message like, so for this type of examples, can you share the solutions I got stuck? So the thing is, there is not a singular solution that is going to be usable for every single object. There is a solution per situation that you're in, and your job is to balance all of the, let's say, situations that you went through to the situation that you're in that gives you the most balance and the most optimal result. So that is going to be kind of like the true solution for situation. And once you have this, then you're going to be more prepared when the time comes to deal with this part. So even when you have that part, let's say, so can you now continue forward And can you, let's say, rebalance this piece with the topology itself? So that's now going to be the next test. And the next test is going to be recreating now the whole thing. Once we have, let's say, this original, not original, but let's say that we have a concept idea. Can you now recreate this? Let's stay with 24. And let's maybe push the same bevel here. And now we need to recreate this part, because remember now, since we have created this block out, now the idea should be a little bit more clear on the steps that we need to do. So first things first, if we are looking at this as our reference right here, so for now I'll just hide this one, keep it to the simple part. So what we need here is going to be the loop that goes here straight on this axis. And that means that we cannot have these loops right here. So this needs to go. All right, so once we have that, then we are just going to connect and balance it a little bit better, let's say around this area, so that we have a quad here. So that is going to be, let's say, enough that we can actually extrude here something. And now comes the thing that we need to know, okay, if this cylinder count, if this segment count is maybe a little bit too strong for us, then probably we're going to need to address the cylinder segments. So for now, I'm not going to do that. I'm just going to then stick to what we had here. Because right now what we would need to do is we would need to kind of like readjust the segments of the cylinders to match maybe a little bit better to the thickness here. But like I said, just to keep this going, we're just going to establish this form right here. And then we're going to need to have a form on the side. And let's say push this to the side, and there we go. So now we have this parts. The next thing is going to be pushing these parts up. So let's deal with this. And this is going to go up, and then let's say this is going to go down. So now we have, again, established at least, let's say, a base that we can now work with, and then clean the topology forward, and then let's say do a proper support loop, do proper edges and whatnot. And now the new game begins. A new game again is that one that we had at the very beginning. Can we actually isolate this? If we're not sure where the edges flow, now that we have, let's say, a different structure here, do we now know how to balance this? So again, just following that natural flow technique, we're just going to balance it with, let's say, a topology count like this, maybe rebalance it even further. So I don't know, give it something like this. And then now we have a test where we can see that the density itself, so like is holding, let's say, this corner right here. And if we were, even though that I'm not a fan of borrowing, but even if we would, let's say, borrow a corner here a little bit, would that fit to the support loop that needs to go around here? So if I add bevel edge here, and if I add support loop, would that kind of like fit if this would be the, let's say, the edge flow? However, we can go this step forward, and let's say that instead of borrowing the edges here, what if the loop would go all around? So then we would have something like this. And then also we would have a support loop there on the top. And because of that support loop on the top, we could redirect this piece, but we cannot really redirect the bottom. So in that case, also one thing, please don't do this, because I saw this so many times. When you see this arrow, that just generally means you're going to get a lot of deformation in that area. So instead, what you're going to need to do, push it one up, check it again. If you're getting this arrow, continue moving forward. So the next thing is going to be then the next one. So this is going to be the next redirection, and now we have a little bit more space, and now we can fix that in this sense. Again, let's do another test. Now the test is going to be, what if I decide that this is for me too much and I want to stop it right here? Then all of this needs to go. And then what I can do is just quickly set this to a triangle, it can stay a triangle. Even though if I'm worried about a triangle, I can always close it like this. But since, again, surface is flat, and this is what I mean, like understanding the surface so well that you know which rules you can bend, where, why, and for what reason, that means that there's no real need to actually kind of like worry about these triangles, because there is not going to be any sort of like impact on the surface, and we're still saving, let's say, some polygons, getting maybe a little bit of sharper edge, just in case that edge needs to be a little bit more tighter and we are looking for a different solution in this area. So these small tests are going to be very, very relevant, because they will determine sort of like that metric on how well prepared are you to now continue this form forward and, let's say, creating these forms a little bit more effectively. So that is going to be kind of like that general approach, general breakdown, just by using blockouts and using these kind of like small tests to see how well are you prepared to any new steps that are coming after, let's say, the steps that you are right now. I hope that makes sense. All right, so now that we have discussed that, let's then go to a new example. So the next exercise is going to be breaking the parts down and making sure that we have balanced topology, or preparing the topology, let's say, for the parts that we need to create. So how that is going to look like is going to be like this. So if you have a piece like this, you're going to deconstruct it down to its most basic form, just to see how well you can actually build from that form up. So first things first, we're going to need to balance the topology here. So let's then connect all the parts that we need to connect here. So this one, and one thing I would suggest is removing every single edge that it's not contributing to anything. So I don't know, this at the bottom can actually go, but the edges that do not contribute to absolutely nothing, you can just simply remove. And again, kind of like connecting these to here, and more or less this is going to be kind of like the base thing. Now we can push this a little bit more further though, because I would like to maybe balance this piece a little bit better, so that this corner is actually more tighter, and push this one also and making this corner a little bit tighter like that. So now once we have this, then we can, let's say, continuing with balancing. However, now you notice we encountered a problem. So the problem here is that once we're adding the support loop here, the support loop goes all the way down. And obviously this is something that we do not want to do. So why we don't want to do that is because we already have established a curvature here. And now when we're adding, let's say, this edge loop right here, this loop is breaking the curvature. So that means that this cannot go. And now we need to kind of like rethink our approach. Well, if I'm then adding, let's say, the edge loops here, and now what happens with this area at this point? Because ideally what I want to do is I want to have, let's say, a balanced topology. And in a sense, when I mean balanced topology with the natural flow, we do not want to have edges that go into redirected areas. So that means that we need to rework something first. So rework is going to be coming in a sense of a support loop. So let me also show you that. So before we continue, we are going to need to add one thing, and that is going to be a support loop here on the inside. Now, why that support loop? Because that support loop is actually going to hold the corners here, here, and here. And then we sort of like effectively solved a piece of a problem. It looks very similar, but here's now the deal. Now we are free to add this natural flow that initially we could not. So again, natural flow means that we can freely add support loops, and doesn't matter how many support loops we're adding, we're still maintaining, let's say, the balance on a surface. So here, instead of 3, maybe I will add 2, because our goal is to create this balance, more or less. You will never reach pure kind of like quads, in the sense that all times all surface has the same quads. That is going to be more or less hard. But what you can do is that, again, more or less the surface is similar, that it has similar, let's say, sizes. Now we have one thing here. in the middle, which also can be reduced, of course. So we can reduce this, we can reduce this, and then we have something similar. But again, rule is observing the reference, and the reference shows that this loop here in the middle actually contributes to the form. So even kind of like technically, if we are following the rules of the topology, we are going to have those variations where we're now practicing exactly that. Observing the rules means, again, understanding the rules so well that you can know when to bend a rule and when it can stay. So this would be kind of considered that cleaner topology, but that cleaner one does not really benefit the form because our form is going to be, I don't know, pushed either from here, or let's say either from here. And let me turn the symmetry off. So our form is going to be pushed from here. So if I do it without, I'm losing the structure in the front. So I'm going to get, let me also add quick support loop here. I'm going to get much of a softer or smoother form than I would get here. So this is the highlight that we're looking for. And moving even forward, now what we are going to do is just add a support loop on the top, because now the only thing what we need to do is just tighten everything. So let's say, let's build this one. Let's build this one and let's add support loop here. And this one here and this one here. So now the question is, what about support loop here? Because that was the example that we had at the beginning. We would now struggle with adding support loop here, trying to understand where to redirect what and for what reason, without realizing that actually our reference is this and not this. So for that reason, again, what we are doing, we are creating this sort of blockout states that we are just remembering as we are creating, that not every corner will going to have, let's say, that let's say technical or by the rule support loop, because in a sense this already is a support loop. It's just a little bit wider and it's holding the corner in the same way that we actually need it. So this is not going to be that balanced topology. If we would need, let's say, a tighter corner or slightly smoother, that corner will depend on one factor, and that factor will be how balanced this topology is. If you would need to have a tighter corner, probably this whole area would be also a little bit tighter or a little bit more balanced, and then we would get tighter corner. If that would be a even softer corner, that would mean that even less topology would be here, and instead of 2 here, we would maybe add 1. And this is basically how we are using, let's say, topology in our advantage to balance the highlights, to balance the forms, based, let's say, on the references that we see. So this is going to be that test, or these are going to be the exercises that you're going to need to do to balance, let's say, the topology itself, just to see again the density levels that you're going to need per each situation. So let's say this is going to be level 1, level 2, and then level 3. And again, the purpose of this exercise again is if you did a good job so far, that means that the more topology you are adding up, it is going to stay stable. It is going to maintain the same integrity as it was here, or here. It doesn't matter how much density you're adding, it's always going to stay the same. And this is again kind of like the test to see how well did you actually approach this kind of like initial state. And when you compare the three, let me add just quick material here. All right, so now with the material, we can observe the corners a little bit better. So first is going to be that lower level topology, giving smoother corner. Mid-level topology is going to get, let's say, mid-level corner that it's not too smooth and not too sharp. And then finally, higher density is going to give us slightly sharp corner. One thing here you can notice is that we did not use almost any redirections. And this is what I like to call kind of like that natural flow, which is going to be that effective way of quickly moving through the form and not worrying too much where to redirect to what, and kind of like to aim for, let's say, specific highlights on a surface. Now, next factor here is going to be what I mentioned at the beginning. Understand the purpose of your practice, understand the objects you are creating and what is their purpose and what is their use. Because rules are going to change if, for example, you're going to need to have this highlight right here, but this form in itself is going to be the final form. There's not going to be, let's say, any further detailing. There's not going to be any further development. What you see is what you get. In that case, you would not add a density. You would not play with the density. You would go for maybe a little bit more optimized approach on the topology itself and maybe play with kind of like redirections even. So in this case, if you know this is kind of like your last stance, so to say, in that case, you can maybe play a little bit with so like redirection, kind of like rebalancing the things your way and kind of like pushing the points to the side, kind of like aiming for that perfect highlight while maintaining that balance of topology. Same thing is going to be then maybe here, you're going to be a little bit more free in kind of like removing some parts out and balancing the pieces. Still in the sense that more or less topology is balanced for the UVs, kind of like that UV unwrap that you get most optimal unwrap like that. But overall, this is then going to be enough if that is sort of like the last stand, so to say. However, if it's not, if you know that this is just kind of like that initial state and now you need to progress further into detailing and furthermore, then in that case, this density is definitely going to be beneficial, or it's going to contribute or benefit the surface in the long run. So again, understanding the purpose of the surface, why you're creating specific things, is going to also determine the workflow or the method or the approach that you're going to use here. So that is going to be kind of like the approach, let's say, for, let's say, creating a breakdown from a simple block out to kind of like these kind of like small tests on which approach or with which method, which highlight is going to be most optimal for the results that you're looking for. Now, the next exercise here is going to be approach to details. We're going to do here 2 exercises. So this is going to be the first one, and also you're going to see the reference here on the screen. So here the goal is, if you're, let's say, trying to recreate something and you see, let's say, a detailed, let's say you see a detailed object and you're not sure how to approach specific details or at what state those details come to, the purpose of this exercise is going to be to show basically what type of topology you're going to need, what topology structure you're going to need, and what density you're going to need. So the thing is, the smaller the detail on a surface, especially the smaller the detail on a larger surface, that is going to be an indicator that you're going to need to have a denser topology. And that is just how it is. So we're going to, again, do one small test here. One test is going to be, again, related to the same approach that we did at the very, very beginning, which is going to be kind of like that Boolean approach, kind of like so to say. So if we would have, let's say, a detail, again, based on that reference, if you would do kind of like Boolean here, let's say this would be similar to the detail that we see. So this is now our reference of what we need to create. So I'm just going to put it aside. And now the question is, what does the reference show? So does the reference show that we have, let's say, this type of angle there? Does it have this type of angle? Or does it have that extremely sharp angle? So if we do kind of like segments here, or is it this angle? Because all of that matters. So what you're going to do, again, in the sense of that detail, whatever you see on a reference, you're going to do small tests again like this. Once you have that, then you're actually going to go into that topology work. So in this case, I can just quickly change the symmetry here from that was X, so it can stay like that. Let me just quickly add here mid loops and then bring symmetry back. All right, so now we're going to do proper topology here and then do those tests. Test number 1 is going to be this part right here. So actually, before we do that, what we can do is 2 things. We can create an offset here first to create a support loop, just to give us some wiggle room and to establish support loop on the outside, because that is going to be, so I'm going to show you what I mean. Let me just, what I want to do, fill hole. So the reason why we do this on the inside first, because if we do it otherwise, we will not get these loops having straight as they are. Because if you, let's say, create a cut from here to here, let me just quickly demonstrate that. And let's say this is now a cut. So fill hole, not fill hole, bridge. And here's going to be a fill hole. So let's say that is the cut. And if we are going to now create a support loops here, what happens is that these loops are moving to the side. So if you can choose between the two, usually I just prefer, for that reason, kind of create support loops at the very beginning. Then I just keep these loops in place. It's not a deal breaker, but still kind of worth mentioning. All right, so let's move forward. And here we're gonna need to have 3 loops. So we're gonna connect this one here, and then this one here. And let's say, I don't know, we can add one in the middle. So that is now one approach. And to test everything, again, I'm going to need to have another variation here down, which I'm just going to isolate. And I'm just going to need to kind of like to test everything, actually create support loops all over. And you know what? Just to save some time, I'm going to delete the back. All right, so now we have support loops all over the place. The only problem is that here on the inside, we have support loops going all across the mesh. So usually what we would need to do is we need to create here on the inside also a support loop, kind of closing it all down, because right now what we are getting is a little bit too soft of a result. So let's do that really quick. So 2 methods you can do this is just select everything. That's going to be kind of like the quickest one. Add a small, let's say, offset on the inside like this, and connect these points and delete. So you don't have to do kind of like manual adjustments around it. And there we go. So now we have support loops everywhere except here on the inside where we have this soft corner. And now to push this even forward, we are now going to create a sharp corner here, which is going to be our classical redirection. All right, so now we have 2 results. We have low-level topology, no redirection, redirection. No redirection gives a softer corner, redirection gives us a sharper corner while maintaining that low-level topology. However, if this is now the only approach that we know, again, I mentioned that in a video called Topology Overshadowing the Art. And the reason why I called it that way, because if this is now the only way that we can actually add sharp corners, we are always going to try and brute force this redirections everywhere we can. So what can happen is that then when the time comes that we need to, let's say, create a detail like this, we're going to notice a lot that we're going to struggle to, let's say, redirect corners somewhere. And in your previous example, you saw that we haven't used any sort of like redirections, and we still managed to control the corners very well. So now we need to do an additional test here, and that test is going to be now related to the topology level. So let's push this to the side, and I'm gonna hide this for now. So let's do another test here, which is going to be based on a topology count. So in order to do that, I'm going to need to delete actually some of the parts here, which is going to be this one. And also I'm going to delete this right here. And then just again to have things a little bit easier on us, I'm going to go directly here and create support loops. So now we're going to test that density. So how much, because like we mentioned, the smaller the detail, the more density we're going to need. So this is now mid-level. We tried low-level. This is now going to be a mid-level. So again, not bevel, but bridge. And then let's go to fill hole. And now the same thing. What we can do real quick here, again, just a small extrusion on the inside. That is going to be kind of like one approach. The second approach would be if you were to connect edges manually like this. That would be kind of like second approach. So this one might give a little bit more kind of like distortion on the sides, but for now it doesn't matter. And there we go. So that is now one approach. However, we are still not done. Let's try one more. Because like I mentioned at the very beginning, what we need to do here, we need to test as many, let's say, options that we can get. I'm going to show you one more, but again, this is not, let's say, now solution for every single situations. What the goal here is that we are kind of like exploring all of the situations that we can get, so to say. So this can go here, this can go here, this can go here, and then this can go here. So what we did here is we connected everything in a triangle. However, that is now going to be impacting the surface, because if we subdivide this, we're going to see that the surface itself is going to be a little bit more kind of like showing pinching in that area. But again, what we are doing is we are exploring everything so that we actually know when the time comes what to do. So let's continue, let's say, forward from this. What we can do is now actually let's say solve some of the triangles if we can, because what can happen is we can, let's say, redirect this one. We can have quad here, but we stay with the triangle. Or what we can do, again, moving forward, we can connect this one here, this one here, and then we get this. So now we have kind of like more quads. So this is why exploration matters, even on those smallest details. So again, if we check the reference, detail is small, but if you do not know how to do this on a basic stuff, kind of like do this exploration, the chances, again, once the time comes that you actually implement that detail in your work, you're going to get stuck, because you're going to notice that the topology that you, let's say, work with so far, it's either insufficient, or it's not balanced, or you're simply not prepared for the approach that you, let's say, want to implement, simply because you did not practice, let's say, that implementation method in the first place, which is this one right here. So if you do not practice this, or if you do not know what to do ahead of time, then when the time comes, you're going to notice that you'll struggle either for the topology, or you're going to struggle in not knowing where the redirections need to go. So this is, again, just that small example. So moving forward then, what we need to do here next, I'm going to just take then the first example. For now, ignore the second one, because first example is going to be, let's say, that soft corner, and then the third example is going to be, again, that redirected corner. So again, natural flow comes first, redirected flow comes second. All right, so now again, we have two set of examples where we can compare the results. So low level, natural flow redirection, and mid-level natural flow and redirection. So if we're again now comparing to the reference, which of these would sort of like fit the best into, let's say, the workflow that we need to go with? So if we're kind of like sticking with low-level topology as far as we can, probably if we are using natural flows, we're going to get maybe a little bit too smooth of a result. If we're using redirected flow, we can redirect for sure, but there's a chance that we might get maybe a little bit more sharper corner in that area. So we need to be sure if we are using redirections that we are then smoothing that corner a little bit more. Again, the rule is going to be if we do not plan to add any like detailing forward or any more excessive details more than that, and if we can get away with redirection, probably then this is the approach that we are going to go with. On the other hand, if let's say this corner right here, what we see is kind of like more in line with the corner that we actually need, where let's say the natural flow itself is preserving the corner as is, so we get this kind of more of a softer approach, then this one is probably going to be just enough. Now the question again is going to be what level topology is going to be enough, because if this is going to be enough, or do we need to going to increase? And like we mentioned before, the smaller the detail, more topology we're going to need. So again, for every single detail that you're creating, you are going to need to have the same set of, let's say, examples, the same set of tests, just to see or just to test what level of topology you're going to need to hold that detail. And also, do you actually understand the process behind creating that detail and fitting it, let's say, into position in the first place. So yeah, this is then going to be it for this exercise. All right, so now the next exercise is also going to be connected to the details, but maybe those details that are, let's say, slightly more, or at least that they appear slightly more complex. So the approach here is going to be, again, exactly the same. So just a small breakdown. If you see a detail, again, same what we see here in the reference, is going to be just a block out of that detail. If you're not sure how to create it, if you're not sure, let's say, how to approach it, you will not start working on a project and then thinking about implementing that detail later. Instead, what you're going to do, you're going to isolate that detail again in this sense, create a basic block out of that, and then build from there. So if you're not sure how to create this, then what you're going to do is going to simplify it even further. So how you could simplify it is create the detail you're going to need and then simplify. So I'm trying to now delete this piece. So simplify in this sense, simplify in this sense, and kind of like just connect everything together until you get this like basic form like this, which is finally this one. So once you have this form right here, then you just work on this piece in the same manner like we covered so far. You are going to create this natural flow first. From that natural flow, you're going to create redirected flow, and then from that redirected flow, again, you're going to test, let's say, the natural flow with more density and compare the results and see which type of highlights you are getting per each. So again, natural flow, low level topology, soft highlights or soft corners. With redirected, we are getting, let's say, sharper corners, but at the same time, we are maintaining low level topology, and here no redirection, density is holding the form in itself. So that is now your kind of like initial state and initial start. The next question now is, all right, so which of these then is going to be, let's say, more beneficial, or which of these is going to have, let's say, more sense to apply for the details that we're going to have? So again, that rule is going to be the smaller the detail, more density you're going to get. And in this case, you can now test with both of the approaches here. You can now take this approach, test the detail. You can take this approach, test the detail, because you're going to have to test both to know, again, which level of topology is actually going to be necessary. If you, from the very start, know that there is a good chance that, for example, depending on a positioning of the detail, again, based on the reference, you might struggle with redirection, then density is going to be your best bet. If you don't mind, let's say, the redirection, if you do not mind, let's say, the pinching that comes from redirection, especially if it's on a curved surface, then you're going to go with this approach. But again, for that same reason, you are going to need to test both. So we can start, let's say, then with this one. All right, so now we have a base to begin with. So to begin with in the first place, I just want to make sure again that I have symmetry at least somewhere. And yeah, then we're just going to maybe start from here, create an offset, but just again making sure that I have everything here selected, and then do another one. So I don't know, let's say something like this. Actually, now I noticed that it's a bit too far away. So it's actually coming from here. And yeah, so now we're just going to need to push this maybe down here, bridge, and then let's say fill hole here and fill hole here. We're gonna need to have a loop in the middle. And to make things easier, we're just going to work on 1/2. So I can delete this one. Again, just to make things a little bit more easier. All right, so now we have a base to begin with. I'm gonna switch also the symmetry to the Z-axis. And is this in the center? All right, now it is. All right, so now the only thing what we need to do is we need to deal with all of these corners. So just connect every single corner where it needs to go. So this one will go here. Then we'll continue this one, and then we're just going to continue everything until we fix all of that. So continuing this one to here, this one to here. And again, what we are doing here is just that test on how well prepared are we to create the detail that we actually see. Because if we're kind of like stuck here, or if we're not sure what we are doing here, then the chances are that we're going to just get stuck there as well. All right, so now we have this, and the only issue here is now we need to kind of like deal with all of these corners, because these corners don't really look like that. So this can go and this can go. Then we have this corner, this one on the top. Now the question is, do we use kind of like that our classical redirection, where we don't need this one, where we don't need that one, but we actually going to need those on the top, so maybe they can actually stay as it is. And yeah, let me just double check here. So the problem here is that we are getting is that this loop is going to be a little bit too far, and maybe we're going to need to have one loop just to tighten this area and make sure this is like evened out. And what we are getting here is a little bit too soft of a corner. So what we are missing here also a loop on the bottom, because we need to also kind of like tighten that up. So we are getting this little highlight. Now the next step, what we need to do here, we need to test this piece with redirection. So let's go bevel edge. This stays on, and then we are redirecting this one. And yeah, so now we have two set of results that we can actually compare. So again, natural flow, redirected flow, again, based on that original redirection, and this is the results that we are getting. So there's a lot of redirection here, so a lot of stuff to play around with. So let's then now do the same thing with this one right here. Detach, and then we're just going to work on 1/2. So the same rule applies. Now we just need to kind of like solve here everything that we can. So this would go here down. If we are so sure, we can go directly into, let's say, the edges that we actually need. So let's say directly into this. This one will go here. This one will go there. And then we are closing this one here. And we need a support loop here as well. And here we're gonna need
अच्छा उसके बाद पहले तो मोबाइल में ज़्यादा क्लिक करते हैं तो वाली लाइन आती है अच्छा तो ये भी दो जगह से आता है एक नॉर्मल पिकअप से और एक सीपी डिस्चार्ज वाला हेडर होता है तो उससे अच्छा तो दोनों कॉमन होते हैं अच्छा फिल्टर के थ्रू उसको हेडर में डाला
This, by the way, also works if you quickly want to explode your mesh. And click on Bridge Edge Loops. Is still in this place here, which is super cool. This is nicely projecting the mesh, increase the count of the ray modifier, and then we have full control on our arm here. Hi everyone, Zach Reinhardt here for cgboost.com, and I'm a little bit late on this video here because recently our YouTube channel reached 100,000 subscribers. Well, not so recently, because we are actually at 120,000 subscribers right now, so I'm 20,000 subscribers late. Anyway, YouTube sent me this nice package here, and it was lying here in my office for weeks now, because I wanted to finish this video here first and then unpack this together with you guys. And yeah, let's do it. This play button was packed by Rick. Thanks, Rick. And oh my god, that's the play button. I don't know if you can see it. Presented to CG Boost for passing 100,000 subscribers.
I've been doing certificate courses in interior design with And Academy here, and it has been a really wonderful experience. The curriculum, the way everything was framed out, was really very simple for us to understand how this entire process.
Let's put it here somewhere. Yeah guys, and this play button we only got through your support, so a huge thank you for all the support for all the years. Thanks a lot. So yeah, and why does it took so long? Because editing and putting together this video was a huge undertaking, as you can imagine. Anyway, in this video I packed in over 100 modeling tricks, and modeling tricks in a broader sense. That means basically everything that can help you to speed up the creation process of 3D objects. That certainly includes edit mode tricks, modifier tricks, but also a bunch of user interface, navigation, selection tricks, and so on and so forth. But anything some kind of related to 3D modeling. And the best thing is, for all the tips I show you here, we only use Blender internal tools or add-ons that are shipped with Blender anyway, so no external add-ons or paid products required. This contains a lot of tips I use a lot in my daily work, some things I've learned recently, and also some nice tricks I learned from colleagues and friends like Juan Hernandez, Julian Kasper, and Jan van den Hemmel, besides probably a lot of other people I can't remember. So thanks guys. And yes, it is a very long video, but to make it easier to consume, I added a whole list with all tips down below in the video description, including timestamps which you can click on, and categorized in different chapters, so you basically can just click on the stuff that interests you. In this video you will learn a lot of shortcuts, and I know it's hard to remember them all, and that's why we created the Blender Hotkey PDF, which contains all the most important Blender shortcuts in a beautiful and print-friendly PDF file. And the best thing is, we keep this updated when new Blender versions come up. If you want to grab it, you can sign up to our free resource section / mailing list, including not only this Blender PDF, but also a full free Blender beginners course and many other tutorials and the project files for our tutorials. And it even includes a downloadable version of this video here, including this robot blend file. When signing up, you will not only get these nice resources, we will also send out some very useful emails which will help you to grow as a 3D artist, and we will certainly keep you up to date with our content. And if you don't enjoy these emails, you can unsubscribe at any time. Also, if you're new to Blender, you might enjoy our top-rated Blender 2.8 Launchpad course, which will teach you everything you need to learn to get started with Blender. And in addition, there's a huge UV mapping and texturing update coming soon to the course. Stay tuned. If you feel that the modeling tips in this video here are not enough for you, I highly recommend to check out the YouTube channels by Josh Gambrell, Gleb Alexandrov aka Creative Shrimp, Adiburs 3D, and Arimos 3D, to name a few. They focus heavily on hard surface modeling, and I'm sure there you will learn a lot more awesome modeling tricks. In addition, I can highly recommend the Hard Surface Modeling course and the 50 Modeling Issues from Hell course from Creative Shrimp. And if you love these short Blender tips, I can also highly recommend the amazing Blender Secrets ebook by Jan van den Hemmel, which contains, I don't know how many, but multiple hundreds of Blender tips, including modeling tips, but also including tips to any other Blender topic you can imagine. I'm pretty sure that these courses and this ebook can level up your game as 3D artist a lot. You can find all the links down below in the video description. Just to be clear here, the links to the courses and the ebooks are affiliate links. That means if you decide to make a purchase, we will get a commission with no extra cost to you. However, I'm only promoting stuff which I'm fully convinced of, so I'm pretty sure when you get one of these products, they will help you a lot. And since people ask me this a lot, if you're interested in my computer specs, I also listed them down below in the video description. So guys, I know this was a long intro, but without further words, enjoy the ride. When you select an object and hit tab, you switch to edit mode, which is nice. However, sometimes you quickly want to switch to the other modes and you don't want to go up here and select the specific mode from the list here. What you can do, you can press Ctrl tab and hold this to open up the mode pie menu to quickly switch to another mode. You can hover over to edit mode, for example, and just release the buttons to quickly switch to edit mode. And the same works for all the other modes, as you can see. However, since this is a shortcut we use a lot, pressing Ctrl tab feels a bit weird. So let's go to Edit, Preferences, and here under Key Map, you can either check tab for pie menu. That means if you press tab, the pie menu appears immediately. Or if you still like the single tab press to quickly switch to edit mode, you can also enable pie menu on drag, which I have enabled. If I now press tab, I switch to edit mode, but if I hold tab and move my mouse in a specific direction, it opens the pie menu, and then I hover above the specific mode and then release my mouse. And this allows us to switch to different modes in less than a second, as you can see. As you probably know, up here you can change the viewport shading to wireframe, solid, material preview, and rendered. However, if you don't want to always go up here, you can also use the shortcut Z, which by default is just switching between wireframe and solid viewport shading. However, if you hold down Z and then move your mouse in a certain direction, you can see this pie menu pops up, which allows us to quickly change between different modes. Besides changing the viewport shading, the X-ray mode is very useful because it let us see through objects, and in edit mode it also allows us to select anything which is on the other side of the mesh. And for that, there's also a shortcut. Simply press Alt-Z to turn it off and on. I'm in solid mode over here, and you might wonder why the surface of the object is reflecting. And that's because if I click this little arrow here, I change to matte cap, and here we can pick a bunch of different matte caps, like this one here. And these matte caps allow us to see surface imperfections better. As you can see over here, I added a few bumps to the surface. If I switch back to the studio lighting, you can see it's not so easy to tell. And there are special matte caps like these ones here, which looking super crazy, but they allow us to quickly identify bumps in the surface. We also have the vertical lines here, as you can see, or this matte cap over here can also help us to define surface imperfections. But usually when I work with very smooth surfaces, I either pick the red one or this one up here, which also gives us a good understanding on how smooth the surface is. Up here on top of this shape, I have a nice big face, right? No, it's not a face. It is a complex geometry, as you can see. However, when we take a look from above, we can't really see all these details. This can make modeling harder. However, if we go up here to the viewport shading settings, we can enable cavity. Here we have two options. We have the world cavity, which basically adds some kind of ambient occlusion effect. And we also have the screen cavity, which in this case is a bit hard to see. If we make it a bit stronger, you can see this adds this very bright edge to the sharp edges and this dark edge to all the corners here. So screen is very sharp and thin, and world is soft and wider. You can also control the strength over here. And if you click on this gear icon, you can also change the size, the distance. And under type, you can also select both to have a mixture of both. And then you can set up the strengths for each of them individually. And now we can see the surface of the object very nicely because we can see some kind of depth of the whole shape here. When working on your scene where you have many different objects, it can be sometimes hard to distinguish which object is separated from each other. And to make this easier, we can go up here to the viewport shading settings and under color enable random. This will give each individual object a random color. Here, for example, without selecting this, we can see that these two cylindrical shapes belong to the same object. This little feature here is a lifesaver. When you select an object, you can hit period or comma on the numpad depending on what language keyboard you're using, and this will center this selection, as you can see. This can be super useful to quickly navigate through your scene, and sometimes you maybe get stuck while navigating your scene. This can recenter everything around the object of interest. And the cool thing is, this not only works in object mode, this even works in edit mode. Depending on what you have selected, you can center the selection. And even cooler, if you have a long list of elements in your outliner and something is selected over here, you can use the same shortcut to center the selection over here. However, when you don't have a numpad, you probably should buy a keyboard with a numpad because it's super useful when working with Blender. However, you can always click on View and click on Frame Selected. Here in the outliner, you have to right click, go to View and then click on Show Active. Being able to navigate fast and efficiently in the 3D viewport is super important to speed up your modeling process. However, the default navigation settings in Blender are not really beneficial in most cases, because when rotating, we are not really rotating around what we have selected, as you can see, and when we're zooming in, our view can get stuck at some point, and this, especially for beginner users, can be really frustrating. To get out of this stuck situation, you can use this frame selected shortcut, period, on the numpad, which I showed you in one of the previous tips. However, there are some other settings we can enable which makes navigating much more fun. For that, we can open the preferences over here under edit. However, in this case, let's change the properties editor to the preferences, so we have them open all the time. Then navigate to navigation. And first of all, as you can see, by default, we are zooming in and out just straight into our scene, no matter where our mouse position is. And we have a nice option over here, zoom to mouse position. If I enable this, you can see we are now zooming to the position of our mouse. And this alone gives us a lot of control to navigate our scene just by zooming out, changing the position of the mouse, and then zooming in once again. Then the next feature, which is super helpful, is auto depth. This detects geometry underneath our mouse cursor, and this allows us to really zoom into where we want on the surface. And this feature helps us to avoid this getting stuck problem. As long as there's geometry underneath our cursor, we can basically zoom in and out without any problems. And the last feature is my personal preference. This is orbit around selection, which in some cases is pretty nice, but in other cases it's not. So you have to try out if this works for you or not. This allows us to simply select anything, and then when we rotate the view, this will orbit around the selected elements, which is super helpful in my opinion. However, if for example you have something like this selected and want to look around down here and then rotate the view, it is still rotating around the selection, which then can be confusing. Certainly you can select the element over here, but imagine this is like one big object and you want to take a look around down here and the center is up here, then this is really hard to get into the frame. So in this case, turning this off would make more sense, because then we can easily rotate around our current view basically. However, in most cases, I have to say I really like this option. In addition, orbit around selection also works in edit mode. That means if in edit mode you select anything, it will orbit around the selected elements, which is pretty nice. And this even works in sculpt mode. If I sculpt on any place on the surface, it will orbit around where I have sculpted last, which of course can also be super helpful when sculpting something in sculpt mode. So here we have a long list of elements, and sometimes, for example, when selecting the head, it can be helpful to basically hide everything except the head, or if you select multiple objects, to hide everything except the selected objects. You maybe know the shortcut H to hide the selection, so we could press Ctrl I to invert the selection and press H. However, sometimes you have objects hidden and you don't want to unhide them. That means when you do this, you always unhide all objects. That means also all objects which you have hidden and you don't always want to show again. And even when working with the eyes, this can be quite time consuming to pick the right objects. So let's press Alt H to unhide everything. There's a better way to deal with that by using the local view. Simply select a bunch of objects or just one and then hit slash on the numpad. Now you can see nothing is hidden over here, but we can only see these objects since we are now in local view. You can see it up here. This is a kind of isolated view where we only see the selected objects. And if we hit / on the numpad again, we get back to the non-local view. However, if you don't have a numpad, again, I recommend to get one, but you can also go to View, Local View and click on Toggle Local View. In addition, if you want to remove something from the local view, you could certainly go back, select the objects you want to have and then go to local view again, but you can also simply select something inside of local view and press M to remove this from the local view. This you can also find up here under View, Local View and then click on Remove from Local View. And then nothing is here anymore. Damn it. So this tip here is kind of special, but can be useful in some rare cases. Let's select this object, for example, go to edit mode and let's select this face here. Now let's hit Shift Numpad 7 and then the view will be aligned to the normal of this selected face. We can also use the other viewpoints like Shift Numpad 1, 3, 7 or Control Shift 7, 1, 3 to view it from the other side. And now since the view is perfectly aligned to the surface of this object, we can for example see that this USB flash drive is not perfectly straight. Same for this thing over here. So we could adjust this. And as always, if you don't have a numpad, you can go to View, Align View and then Align View to Active and then pick whatever you want, for example Top View, and then you can view it from the top of the face normal. Let's assume that we want to work inside of this robot head here, for example, and change anything there. This can be quite hard because the whole object is in the way. We could try to zoom in here and then get inside. However, there's a feature which can help us. Simply press Alt B and then select an area which should be visible and then the rest will be cut off, but just for the view, not like a boolean or anything like that. And now we can go inside here, simply do what we want to do.
As a VFX artist, my world can be anything I want it to be. Sorry!
Hey! Take that away! I can't believe you! I'm gonna call the cops on you! I'm gonna call the cops on you!
Something like this, and then press Alt B to remove the clipping border, and then as you can see the editing was quite easy. When modeling your objects, it can be useful to view your object from different angles at the same time. For that we can enable quad view. The shortcut is Alt-Control-Q and then you can see the 3D viewport will be splitted into 4 different windows. You can also find it under View, Area, Toggle Quad View. Now you can see we have the 3D viewport up here, then we have the top view, front and the right view. And with the default settings you can shift, middle mouse button click, move these views around. As you can see, you can also zoom in and out if you like, but there are some additional options. If you press N, it opens up the sidebar, and then if you go to View, you find this Quad View panel over here, which only appears if you have Quad View enabled, as you can see. If you disable Lock, you're completely free to change the perspective in each of those windows. You can even change to perspective view if you like. And when you're done, simply click on Lock again. Then we have the box option, which allows us, when I move anything here, all the other views will be adjusted automatically. Even when I change the position here, you can see how this also affects the y-axis up here. And when I change the x-axis over here from the view, it will also change up here. So in this way, you will always focus on the same area. And the last option we have here is clip, which adds a kind of clip region, as I've shown before. When I, for example, move this part here to the front, you can see this line here. When I cross this line, this will be cut away, and this will also affect the other views, as you can see, which is an interesting feature and might be useful when working in edit mode, for example. Let's enable X-ray, and now I can see inside here directly and change anything here on the back side of the robot. Yeah, and if you want to turn it off, press Alt-Control-Q once again. When you start Blender, you will be greeted with this splash screen, which looks pretty nice and has some useful features. But if you're not making use of this at all, you always have to do an extra extra click in order to get started. In fact, you can disable the splash screen completely. If you go to Edit, Preferences, and then under Interface, you can disable the splash screen. And if you need the splash screen at any time, since from now on it will not be shown when you start Blender, you can always click up here on this Blender icon and click on splash screen to get it back if you need any option over here or just want to look at this beautiful image. When working in the interface of Blender and hovering your mouse above any option, you get these nice handy tooltips. However, when I record tutorials, I find it quite annoying that every time I move my mouse, these black boxes appear. So I go to Edit, Preferences, and then under Interface we can turn off the tooltips. That means they are disabled now completely. However, sometimes it still can be useful to show the tooltip, but then always going to the preferences and re-enable this can be time consuming. There's a quicker way to do this. If you temporarily want to show up the tooltips, simply hold on Alt and then hover your mouse above a certain value, and then you will see the tooltip. But since this is now disabled in the preferences, by default, these tooltips will not show up. If you can't remember a certain modeling feature or any other feature here in Blender, you can simply hit F3 to open up the search menu, search for this specific feature, and then on the one hand you see this feature listed here with the specific shortcut, in this case I, and then you can also simply click on this to enable this feature. Now you can see I have enabled the inset face feature. Or let's search for extrude. You can see the shortcut over here, click on this, and then this will work. And sometimes also very useful, when I now hit F3 again, it remembers what we have clicked on last, and then we can simply click on this again. Well, it's probably much faster to just use E here, but in some cases when there's no specific shortcut set, this can be quite useful. So let's rotate this here maybe 90 degrees, and sometimes we want to add something to a specific value. Let's say we want to add 5 to the 90. So for that, let me check. 90 plus 5. Okay, it's 95. But yeah, if this is like too complicated for you, wouldn't it be nice to just do it inside of Blender? And we can do it. Simply go in here and type in any equation you want, like 95 plus 20 minus 50 divided by 100. Oh, 115. Nice. And this certainly not only works in the rotation field, it works everywhere in Blender where we can work with numeric values. When working with transform values over here, we mostly have X, Y, and Z listed underneath each other. And there's a quick way to change multiple values at once. Simply left click and hold, drag your mouse down, and then release your mouse button, and now we can change all the values at once. Another very cool feature when you're working with any kind of value is the quick ability to reset values to the default value. You can either right click and click on reset all to default, which will in this case reset all 3 values to default, or reset single to default. However, there's a way to do this even faster by simply hovering above a value and hit backspace. And this works for any kind of values, even for colors, as you can see. However, in some cases it will not use the default value which is set up by default, but it will reset the value to 0, as you can see over here, for example. When you're working with your objects, sometimes you want to place something very carefully, and in some cases it's moving just too fast. In order to fix that, you can hold down Shift, then it will move like in slow motion, and you can very carefully place it where you want. This not only works directly in the 3D viewport, this for example also works when changing values. You can hold down left click on here to move them around, but when you hold down Shift, you can move it even slower. This also works for rotation, as you can see, and even for scaling. When I hit N, the sidebar opens, and this sidebar shows some useful settings, like here the transform of the currently selected object, but we also have some additional tabs over here with the tool settings, view settings, and maybe some add-ons we have enabled. However, sometimes you're working in one of those tabs, but you need information from one of the other tabs. For example, the transform panel over here is pretty useful, and it would be nice to see it all the time, no matter what tab we have selected, and this is possible by simply Shift left clicking on this panel to pin this. For unpinning this, simply click on this pin icon, then this is gone, or you simply right click and click on pin. Then, when I switch over to any other tab, you can see that the transformed panel will always show up. If it is appearing on the bottom, you can certainly rearrange this if needed. And this certainly not only works for one panel, you can do it for all the panels. So you could even pin all panels from all tabs to have one long list of settings here. And this indeed can help to save some time while modeling, since you don't always need to switch between those tabs here. When we do anything here in the 3D viewport, for example, moving this object, this operator panel, this context menu down here appears, which shows options for the last done action, for example, the move action, and I can change anything afterwards, which can be super helpful. However, if I do anything else, for example, rotating this object, it will show a context menu for this last action, rotate, and now I can change anything here. However, sometimes it happens that you, for example, left click somewhere and then this menu disappears, although we have not done any other action. And in this case, if you want to get this menu back, simply hit F9, and then as you can see, we have the rotate menu, and then I can change anything I want. And when you're done, simply move your mouse away. However, this will never ever bring back the menu of an action I've done before the last action. Just keep that in mind. When you want to learn more about a specific feature in Blender, as you know, you can enable the tooltips. However, in some cases, the tooltips don't give enough information about something, so looking into the Blender wiki can help. And there's a quick way to access the specific section. Simply hover your mouse above a specific feature and then hit F1. As you can see, this will then open up the Blender wiki with showing information about this specific feature. So in this case, it shows the documents of the subsurf modifier. So it doesn't work for each individual setting here, although we can find them in the wiki. However, it will lead you to the right information, which can be quite helpful in some cases. And to be clear here, you need an internet connection to make this work. This just opens the website here online, so this is not an offline documentation. However, this doesn't work for all features here in some cases. As you can see here, for example, it just brings you to the overview of the Blender wiki. And I think, especially when you're starting learning Blender, this can help you a lot to learn more about specific tools. Sometimes you just want to select a certain part of your mesh, and it can be pretty time consuming to select all these different elements. In this case, the grow shrink selection feature can help a lot. So simply select a loop or one element and then hit Ctrl+ on the numpad to grow the selection and Ctrl- to shrink the selection. One other selection tool I use in edit mode a lot is the linked selection. That means you hover above the mesh and press L and all the connected faces will be selected. With Shift L, you can also deselect the linked faces. This linked selection has one other cool feature. You can see this mesh has some red marked edges. I selected these edges and then I pressed Ctrl-E and marked them as seam. A seam you need to create UV maps. If I now press L over here and down here in the operator panel, I set the delimit to seam. That means the linked selection will be limited to the area of the seams. So up here I have a bunch of other seams, which can be a great tool to quickly select different areas. According to different properties, you can see you can delimit this to other properties as well. Sometimes you want to select everything of your mesh except one certain part. So you could select everything and then with Shift L, for example, deselect what you want. But the more complex your mesh is, the harder this can be. So let's deselect everything once again. And sometimes the easier way is to do it the other way around. That means I select the area first, which I want to have deselected, and then simply press Ctrl-I to invert the selection. Now I have everything else selected. Sometimes it can be useful to select every second phase of a loop, for example. In order to achieve this, select one loop, then go to Select and click on Checker Deselect. Now down here, you can also check how many should be deselected or how many should be selected. And you can also change the offset. So, and then you can, for example, extrude this stuff and create some pretty interesting results, as you can see. One of the coolest selection features is Select Shortest Path. If you select a face, edge or vertex, then hold down Ctrl and select another one, the shortest path will be selected. Then down here we have some additional features like face stepping. That means the selected faces will not really be connected, but it will use the direct way to connect to the other selected face, as you can see. Then we have topology distance, which tries to make the selection with as few steps as possible. And then we have fill region, which fills the whole region between these two faces, which, by the way, you can also use directly using a shortcut by holding down Ctrl-Shift and then left click select another face. This one is so cool. You can select this one, Control Shift, this one, and the whole area will be selected. Same over here, for example. And also pretty cool, you can play around with the select and deselect features down here. For example, let's put the deselect to 1. That means every second face will be deselected. Sometimes it can be useful to select random vertices, edges or faces on your mesh. For that, go to select and click on select random. Now it will randomly pick elements to select. Down here you can change the percentage, you can pick a random seed, and you can even change it from select to deselect. That means if you have everything selected, you can click on select random and then it will deselect random elements. And then you can use Alt S to deform this, and then this looks pretty ugly. I am in edge select mode. Let's select one of those blue edges here. Here I added the bevel weight to add a bevel to this edge using the bevel modifier. We will learn more about this later. However, this edge is now selected, and if I press Shift G, I can open up the Select Similar menu. And as you can see, I can now choose from different properties, for example in this case bevel, then it will select all the other edges on this mesh with the same property. If we change over to face selection or vertex selection, and then if I press Shift G, you can see we have different properties to choose from, for example, the face normal. Then it will select all the other faces with the same normal. And down here in the operator panel, I can also change the threshold. When I increase this value, it will also select other faces which has a quite similar normal, but is not exactly the same as the selected face. By the way, in object mode, this works quite similar. Select an object, hit Shift G, and then you can pick different properties this object has, and then all the other objects with the same property will be selected. For example, I can click on type, then all mesh objects in the scene will be selected, as you can see.
How am I already underwater?
I'm in the same boat. I'm in an actual boat. Because I've been using Grammarly's AI for years to keep me high and dry. Try it. Grammarly can point out what's missing. Right there. The CEO will want to see a deadline.
Oh.
And here you should connect the projections back to company strategy.
Yeah. Mia, can you do a deep dive?
On it. 10% higher revenue by next year.
I'm sending it in.
Budget and headcounts are approved.
Download Grammarly for free.
अप्सरा हो क्या? आसमान से आई हो?
ये एनिमे हिंदी कैसे बन गया? तूने बताया. Your favorite anime now dubbed in Hindi, Tamil and Telugu only on Crunchyroll.
Since Blender 2.8, it is possible to edit multiple objects at the same time. Simply select multiple objects, hit Tab to enter edit mode, and now as you can see, we can work on all the different objects. However, it is not possible, for example, to connect two different objects by pressing F. This just don't work. If you want to change something in the object related settings down here in the properties editor, if I, for example, go to the modifiers, here you will only see the settings of the object with an active selected element. So for example, if I select multiple faces here, the highlighted one is the active face. And if I change the active face up here, you can see how the modifiers are changing because these are the modifiers of this object. If I select one face, the active face over here, you can see the modifiers over here. So just take care when you change something here in the settings that the active element is on the right object. If you want to connect two vertices across an existing face, never use the shortcut F because this will just generate an edge lying on top of a face. As you can see, I can still select the whole face here. Instead, use the shortcut J to add an actual cut from one vertex to the other. One cool side note, this also works if your selected vertices are lying on completely different places on the mesh. As soon as you press J, it will create a cut through the whole mesh with the shortest path from the first to the second vertex. So now let's add a loop cut over here, and later on I realized that I want to move it down a little bit. I could try to use G, move it down, then scale it a little bit, but this is certainly not the way to go because we are deforming the surface. There's a better way to do it by sliding the edges or vertices along the existing surface by pressing double G. Now I can slide it up and down, as you can see. If you have an edge selected which is on an open mesh, as you can see here, and if I press double G, you can see by default I can't go further than the original mesh was. However, I can either press and hold Alt to extend this or simply press C to keep this enabled all the time. So you can extend the mesh without extruding or anything like this. Let's add 2 loop cuts over here and both are selected. Now let's press double G and slide this, and as you can see, since the faces these edge loops sliding along are different in size, they don't move evenly. For example, if I want to move them the same distance. And for that you can press E, and now both are moving evenly, and if you want to flip the direction you can press F. So it flipped to the other side of the mesh it is sliding along. Let's select this top loop here, and when you press M you can open up the merge menu. And here you can either merge at first selected, last selected, center and stuff like this. Let's click on collapse to merge all these vertices. Let's select this loop once again, press E, right click, so it is extruded but now the geometry lies above each other. So we get some glitches and errors. And in order to fix this, you can also use the merge menu, select everything, press M and click on merge by distance. Then down here you can change the merge distance, and down here you can see how many vertices were removed. So if you want to merge all vertices which lie pretty close to each other, you can increase the merge distance. And if you overdo it, you get some abstract art. Pretty nice. Let's select the whole engine here. Shift D, duplicate this, press G, Z, move it to the top, and rotate this 90 degrees. And now I want to connect these two pieces here. And for that I can enable auto merge vertices up here. If you don't have this tool settings bar up here, click on view and enable tool settings. Now when vertices lie pretty close to each other, they will be merged automatically. So I press G, C, move it up a little bit so that the 2 loops in the center lie above each other, left click, and now as you can see they are merged. Also pretty cool, if you select the whole loop here, you can press double G for the slide option, and if I slide it up here, left click, it will be merged with the other loop here. In addition, you can also enable snapping with vertex snap, for example, and then snap vertices onto each other and they will be merged automatically. When you want to remove an edge or a vertice or a face from your mesh without leaving a hole in the surface, you can use the dissolve options. So here I selected one edge loop, then you can press X, and then as you can see we can dissolve vertices, edges or faces. In this case I dissolve the edges and they are gone and the mesh stays intact. When you have the edge selection enabled up here, let's select a few loop cards. Then I can simply press Ctrl X to dissolve these edges. And this is perfect if you want to quickly remove unnecessary loops from your mesh, for example. There's another cool option. Here we can see this perfect looking face. However, it's not perfect. It has a lot of weird cuts. In order to get rid of this weird cuts, simply select everything, press X, and then click on Limited Dissolve. This will remove all the unnecessary edges and vertices from your mesh so that the volume or the form of the mesh still stays intact. Sometimes this works pretty well, however, in some cases, as over here, if I select everything, press X, Limited Dissolve, this doesn't work perfectly, as you can see, since it removes some of the edges which we still want to have. Down here you can change the angle if you like to dissolve even more stuff, and then again we have some nice abstract art. When you're in edit mode and have something selected, you can simply hold down Ctrl and right click somewhere to extrude to your mouse position, which is pretty amazing and which can be useful to share some love. Did you know that you can mirror in edit mode without using a mirror modifier? Let's join these two objects together with Ctrl J. And very important, now you can see the origin is over here, but it has to be in the center. So right click, set origin, origin to geometry. Now it's in the center here. The object is symmetrical. And now if I go to edit mode, up here I can enable mirroring. To know what axis to mirror, up here change to the local transform orientation and enable the move tool. Go to object mode and now you can see the green axis is the one I want to mirror. It's Y, so let's enable Y up here. And now if I change something on the one side, it will automatically change on the other side. However, this will only work with the existing geometry. If, for example, I start to extrude something over here, this won't work. As you can see, this will deform the other side right now, but this won't extrude anything. So this is only useful if you want to quickly change the shape of an object with the existing geometry and mirror the stuff to the other side. Let's add a loop cut over here, and now I realize that I want to rotate this a little bit more to match this loop down here. However, if I now press R to rotate this, you can see that we will deform the geometry. And in order to achieve this without deforming the geometry, we can use this nice shear tool. Now we can click on one of those axes and kind of rotate this loop here without affecting the shape of the underlying geometry. Let's enable the Move tool, and up here in the Transform Orientations menu, let's check Normal. Now we can select Faces, and the gizmo of the Move tool will change its position according to the normal here. Now we can move this like this. This is pretty cool, but it involves a lot of steps. There's a way to do this even faster without changing anything over here, and this is by using the Shrink Fatten tool, which you can enable by pressing Alt S, and then you have the same effect. This also can be used to make things thicker or thinner, as you can see, or over here to make this bigger, maybe this one a little bit bigger, or let's make this one here a little bit wider, Alt S. And as mentioned, with Alt S you can also make things thicker or thinner, which is super useful. So if you want to close an open hole in your mesh, you can simply select all the edges around it and press F. However, then you just have one big n-gon, but in some cases you want to have a nice quad mesh. In order to achieve this, select the whole loop, make sure that the vertices around the open hole have an even number, and then press Ctrl F and click on Grid Fill. Then this open hole will be filled with a nice grid of quads. Down here in the operator panel you can change the span to better fit your mesh and change the offset, which basically rotates the whole thing. Beveling is not only possible using a bevel modifier, we can also do it directly in edit mode. Simply select an edge or multiple edges and press Ctrl B to bevel this. When scrolling the mouse wheel you can add segments here to make it smoother. After confirming this, down here in the operator panel you can change all the settings. You can change the offset, as you can see, the segments, the profile if you like, and you can even set this to be vertex only. This adds a pretty cool effect. Let's press Ctrl T to triangulate this. There's even a shortcut to bevel vertices directly. Simply select a bunch of vertices and press Ctrl Shift B. And then we can extrude them. Pretty interesting. To add thickness to an object, you can either add the Solidify modifier, or you go to edit mode, select everything, press Ctrl F, and here you can also solidify the faces. Down here you can change the thickness, and make sure when you go into the negative direction to select everything, press Shift N to recalculate the normals so that you don't get any shading issues. Well, that's a thick node. Same as for bevel and solidify, you can even use Boolean operations directly in edit mode. Simply switch over to edit mode, add a mesh element here, maybe this cube here, move it where you want to have it, then make sure that the whole thing is selected. If not, hover your mouse above this and press L, then the whole connected part will be selected, and then simply press Ctrl F and click on Intersect Boolean. Then this will be cut off, as you can see, and down here you can even change the Boolean from difference to intersect or to union if you want to merge both objects. Okay, this trick does not work all the time, but in some cases this can be quite useful. Sometimes you have some open holes in your mesh and you quickly want to close them. One way to do it is to simply select everything and press F. Then all the open holes will be closed. However, then you also get some of these n-gons here. Let's undo this. However, there's a more elegant way to do this. For that, make sure that edge selection is enabled. Then go to Select, select all by traits and click on non-manifold. Now as you can see, it will select all the open holes, and now you can press F to fill these holes, then Ctrl T to triangulate, and then press Alt J to convert the trees into quads. It involves a few more steps, but in this case here you can see this worked quite well. However, in some other cases this doesn't. Up here you probably would use the grid fill option, which I showed you earlier. The knife tool, by pressing K, is a great tool to add additional geometry to your mesh. However, by default, as you can see, it only cuts on the direct surface what we can see, so it will not cut through the mesh. However, the knife tool has the ability to cut through the mesh. Let's take a look from the side. Press K, and then down below in the info bar you can see a lot of additional shortcuts you can press to turn things on and off. For example, you can press Z to enable the cut through feature, and we can press C to enable the angle constraint. So I can make a cut here, and as you can see, this is constrained to certain angles. Now I can make a cut, and with E I can even start a new cut without leaving the knife tool. Let's do it like this and then hit enter to confirm the cuts. And as you can see, this now cut it through the whole mesh. Let's hit Shift A, add a mesh, a new circle here. Down here in the operator panel, set the vertices to 8 and the radius to something like 5. Then let's take a look from the side, move this up here, rotate this 90 degrees. Let's take a look from the front, and now we want to project this circle onto the other mesh. Make sure that the circle is selected, then shift select the other mesh, tap into edit mode, and then simply go to mesh and click on knife project. Now from our perspective, this circle was projected onto the other mesh, as you can see. So it's really from our perspective. If I click on this again, you can see it will project from our perspective. Let's undo this. Let's click on this again. By default, it will just cut on the visible faces here, but we can also enable cut through, and then this will also appear on the other side, as you can see. Let's take a look from the front again. Let's click on cut through. Take care when you click on this, the cut will be done again. So if you are here and click on cut through, something like this will happen. So let's disable this. Now we can delete the circle here. We don't need it anymore. And then we can quickly fix the mesh. Let's add a new loop cut over here. Let's press J to connect these two. Then let's enable auto merge as shown before, and then the edge slide function, which I also showed you before, to merge close line geometry. Then let's delete the faces here, and then we can select this one here, extrude and scale along the y-axis, and use a bevel function to add a bevel here. And then let's enable the subsurf modifier, and look at that. You there, drink more water. You can see this one mesh consists out of 2 parts, and now I want to connect these 2 parts. Let's Alt left click and then Shift Alt left click select these 2 loops here. Important, both loops needs to have the same vertex count, and then we can press Ctrl E and click on Bridge Edge Loops. And now you can see this was connected, and down here in the operator panel you can add, for example, some cuts, or you can twist this, change the smoothness over here, or the profile, which can result in some pretty interesting
I'm like the surgeon, I'm like the general, I'm like the sergeant. Everything you taught me I remember. Lessons learned, they run like waters cleanse me. Situations they taught me.
things. Here's another cool way on how to use the Bridge Edge Loops tool. Here I have this cylindrical shape and I have this circle on top and on the bottom, and I want to create a simple hole here. So I don't want to remove the faces and then manually close the open mesh. Instead, you can simply select both faces here with the same amount of vertices and then press Ctrl E to open up the Edge menu and click on Bridge Edge Loops. And as you can see, this creates the hole for us. This object here is selected and it has still the flat shading enabled. And to make the surface look more smooth, right click and click on Shade Smooth. Now everything looks way better. However, on these sharp edges here, this looks pretty ugly. In order to solve this, we can go to the Object Data tab and under Normals enable Auto Smooth. And then you can see some of the edges will be displayed as a sharp edge. And this can be defined with this angle here, which defines the maximum value between face normals which are considered as smooth. So for example, here we have a 90-degree angle, and if I go over 90 degrees, you can see that this here won't be considered as sharp anymore. So you can play around with this angle until everything fits, but sometimes you don't get the result you want. And in this case, you can go to edit mode, simply select one or multiple edges, Ctrl E, and then click on Mark Sharp. And then this was marked as a sharp edge as well. However, this custom sharp edges will not work if Auto Smooth is disabled. And if you only want to use custom sharp edges and the whole mesh should not be affected by by this angle here, simply crank it up to 180 degrees, and then you can go to edit mode and only select the edges you want to be considered as sharp edges. By the way, if you want to remove a sharp edge, simply select it, press Ctrl E and click on Clear Sharp. And yeah, with this auto smooth feature, you can also make ugly cylinder look awesome. Sometimes your object consists out of multiple parts. Like here in edit mode, I can with L select the underlying connected mesh, and if I move it around, you can see these are different parts. But sometimes you want to work on one of those parts without separating things so that you can better access each individual element. However, here in edit mode, you can also hide elements. So let's select this one here with L. Then I press Ctrl I to invert the selection, and then I simply press H. Then the other two objects were hidden. Then I can do whatever changes I wanted to do here on this object. And with Alt H, I can unhide this stuff. One note here. Sometimes when you hide stuff in edit mode, you might forget that you have hidden this, and then when you're in object mode, you can see everything, but when you tap to edit mode, suddenly this disappears. And if this is the case, most of the time, you simply need to press Alt H to unhide the stuff. As additional note, hiding with H and unhiding with Alt H also works in object mode. Let's select these faces here, and you probably know the Inset Face tool you either find over here or by pressing I. However, what you maybe don't know is when you take a look on these overlays up here, that you can press a bunch of additional shortcuts. For example, Control to move it in or out. You can press O to outset the face, or you can press I to use the individual faces here. Then let's delete these two faces. So the selected faces are close to an open hole here. Now if I inset the face again, we can also press the shortcut B. Then there will be no inset on the edge with an open hole. And in this way, we can give this robot a face he deserves. Sometimes you want to create nice creases. For that, you usually add multiple edge loops around one existing edge loop, and then with Alt S, you can shrink fatten this. This works, however, this is not the best way to do it. One other way to do this is after selecting the edge loops, you can press Ctrl B to bevel this, and with a mouse wheel, you can add multiple segments, like one in the center, then you can select both of them, Alt S, scale them in and out. And there's even a third way to do this. Let's select these two, hit Ctrl Shift R to use the offset edge slide feature. This creates two new edge loops around the selected ones, and you can slide them along the existing geometry, as you can see. However, the distance is different here according to the size of the faces they are sliding on, but you can use additional shortcuts, as you can see up here, for example by pressing E to make them even. With F you can flip them, and with C or Alt you can clamp them so you can go further than just the existing geometry they are sliding on. Then place them somewhere here, select the inner loops, press Alt S, and then you have some nice creases. When you want to edit something in a more organic way, the proportional editing feature here is quite useful. You can see when I grab one vertex, I have this radius which I can change with the mouse wheel to dynamically change the shape of the object. We can even change the offset here, maybe to random, to quickly deform everything. However, this feature is sometimes not so intuitive since we always need to select all the different things. What we can do instead, we can go over to the sculpt mode and use the grab brush instead, which you can also enable by pressing G. And then with F we can change the size. Let's disable X mirror here, and then we can simply drag and drop the geometry, which is pretty cool to quickly dynamically change what we have here. Certainly you can also use all the other brushes to do some crazy stuff with your existing geometry. Whoa. This one object here consists out of multiple mesh parts. If I go over to edit mode, hover my mouse above one part here, press L, you can see all the connected elements will be selected, and when I move it, you can see this is not connected to the other pieces. And this object consists out of multiple such pieces. And sometimes you want to separate all these different individual elements from one object into multiple objects. You maybe know this feature when something is selected here in edit mode, you can press P and click on selection to separate the selected elements into a new object. However, when you want to do this for all individual parts, this can take a while, but luckily there's a fast way to do this. By simply pressing P, you don't need to select anything in edit mode, and then click on by loose parts. And now all the different elements here are separated into different objects. However, the origin, the yellow dot down here, is still where it was originally. However, you can simply select everything, right click and click on Set Origin to Geometry. And now all the origins are kind of in the center of these different elements. Sometimes you have objects which are weirdly rotated in space, but if I check the Move tool, you can see neither the global nor the local transform orientation aligns with the object rotation. But now let's go to edit mode and let's select these faces here, and I want to move them along the existing surface. So when I just try it manually, you can see everything gets deformed and we destroy the whole mesh. However, the first logical thing we would try is to use the normal transform orientation, but as you can see in this case, this doesn't work either. But there's a nice trick in combination with the normal transform orientation, which works like magic. Let's go over to the transform pivot point and change this to active element. This will set the pivot point onto the last selected element, so the highlighted face in this case. And now you can see the transform orientation aligns to this specific face. And in this case, this works like charm. And even cooler, you can even use the transform orientation of faces which you don't want to move. For example, I can select this one here. However, if I would move this now, this face will move along with the rest. But if I shift select this once again, this is deselected, but it's still considered as active element. And the pivot point is still in this place here, which is super cool. Let's select this one here, for example, and move it along here. This active pivot point can also be used to rotate stuff. Let's select this stuff up here, and with Ctrl+ on the numpad, let's grow the selection. Let's select one vertex here. Now if I rotate, you can see this active vertex will be used as pivot point to rotate the selection. The same applies for scaling. For example, let's use the edge selection. Let's move this edge down here. And if I now select multiple other edges, and as last one, this one here, I can simply press S for scaling, log this along the x-axis in this case, and hit 0 on the numpad, enter. And now as you can see, all these other selected edges were scaled to the height of this edge here. Same applies for faces. Make sure that normal transform orientation is enabled. Let's select multiple faces, then select one as active element. Let's enable the Move tool to better see it. And now if I scale this along the Z-axis, press 0, everything is scaled to align with this specific face. Pretty awesome. Let's select multiple faces here, which are not connected to each other. And if I now hit scale, for example, you can see by default everything scales together, since up here median point is enabled for the transform pivot point. However, if we change over to individual origins, and if I now press S, you can see I can scale each face individually. However, if there's a bigger area selected and all the faces are connected to each other, this will be considered as one element when I scale, rotate or extrude. This also works in object mode. If I select everything and now press S for scaling or R for rotation, you can see it is now rotating around each individual origin. Let's enable X-ray either up here or press Alt-Z so that we can see and select through the mesh. Now let's take a look from the front and select the upper part here. Now up here, the transform pivot point is set to a 3D cursor. And now with Shift right click, you can place the 3D cursor somewhere. And when I enable the Move tool up here, you can see that the transform gizmo is now placed on the position of the 3D cursor. That means if I now press R for rotation or S for scaling, it will use the position of the 3D cursor. But take care, by default the 3D cursor will be placed on the surface, so when I hit scale it will also scale to this position here. But this is especially cool if you quickly want to rotate stuff. There's a nice tool in Blender that lets you repeat the last action, but it will only remember the very last action you did. However, when you are duplicating, let's select this one here with L and hit Shift D, it will immediately go to the Move tool. So after duplicating, this is now duplicated, we are now in the Move operation. And now I can log this along a certain axis, for example Z. Let's move it up a little bit and now let's confirm with left click. So that means the last action was not only duplicating, but this also included moving. And now if I use the shortcut Shift R to repeat the last action, you can see it will duplicate and move it for this certain distance. This can be used to quickly create some kind of array stuff if you don't want to use an array modifier, for example. And this not only works in edit mode, this also works in object mode. Let's hit Shift D, don't confirm the position yet, move this along a certain axis, for example, like this, and then hit Shift R to repeat the last action. When you're working with the Boolean modifier a lot, it can be quite time consuming always going to add modifiers, Boolean, then pick the Boolean object and then work with this and then add the next object, add another Boolean modifier and so on and so forth. And in this case, the BoolTool add-on comes in handy, which is shipped with Blender. We just have to enable it under Edit Preferences, search for bool and then enable this. Now simply press N and here you find the BoolTool add-on settings under the Edit tab. And here you have the typical Boolean operations plus the slice function. And now all you need to do is to move these two objects into each other. Auto Boolean will add the Boolean modifier and then apply this immediately. So in this case, I select this one first, the Boolean object first, then the object where we want to apply the Boolean modifier on. And then we can either click on Difference, Union, Intersect, or Slice. And as you can see, no modifiers will stay here, we just have the finished mesh. However, when you want to stay flexible, you can use the brush Boolean options down here. So same workflow, select this first, then the other one, and then click on Difference. And then as you can see, on this object, a Boolean modifier was applied. The cube over here will be set to wireframe automatically, so we can better see what's going on here. And certainly we can also do this for multiple objects. So let's select these two, then this one here, and then let's click on Difference, for example. Then you can see it creates two Boolean modifiers. And over here we can also control everything. We can hide the Boolean objects, we can apply all modifiers, or we can remove all modifiers. And down here you can control the settings for each of the Boolean modifiers, and you can also change the order if you like, and even delete them. Another awesome modeling add-on which will make your life a lot easier is the Loop Tools add-on. Go to Edit, Preferences, Add-ons, search for Loop, and then enable Mesh Loop Tools. And then you also find it in edit mode. When you press N, go to Edit, and here you find Loop Tools. It has a lot of functionalities, as you can see, and I don't want to show you everything. One thing I use a lot, which helped me in many situations, is the circle option. Just click this and it will turn everything you select into a circle if it's possible. And each feature, as you can see, has additional options, but these up here will only be applied when you click this button again. If you want to change this on the existing circle which you just created, you can go down here into the operator panel and change values over here to make it fit your needs better. Now we can extrude this, and then let's also use the flatten function over here, for example. Then let's add the mean bevel weight.
KiloCode is a powerful, open source AI coding assistant that supercharges your development workflow right inside VS Code. But unlike other AI tools that just autocomplete what you're writing or create lines and lines of AI slop, KiloCode is a full development partner that can handle complex tasks across your entire code base. At its core, KiloCode uses specialized modes to adapt to different development tasks. Code mode helps you implement features and fix bugs. Architect mode plans your system before writing a single line of code. Ask mode explains complex code bases without modifying anything. And debug mode systematically troubleshoots problems. Need to handle complex projects? Orchestrator mode breaks them down into manageable subtasks, each handled by a specialized mode. It's like having your own dev team, an architect for planning, a coder for implementation, and a debugger.
And let's also add this to this loop over here. And then you can see we created this nice cylindrical shape very quickly, which is directly connected to the mesh, which is otherwise much harder to do. So check out all the other features you have here. They can help you a lot when modeling stuff. And here's another small but very cool modeling add-on which can make your life easier. Go to Edit, Preferences, Add-ons, search for F2 and enable this. This now gives us the option to simply select one vertex in the corner. So we have two edges connected, and then press F, and this will create a new face over here. Right click and then it will jump back. In this case, you can very quickly close meshes. And this tool is also very useful when it comes to retopology, for example. When you move rotate and scale your object, there's a quick way to reset everything. You probably know the shortcuts G for moving, R for rotating, and S for scaling. And if you combine these shortcuts with Alt G, Alt R, and Alt S, you can reset the location, rotation, and scaling of the object. Let's enable the Move tool here, and then we see this manipulator, this gizmo on the selected object. This can be pretty handy, especially if you up here change the transform orientation to local to see the individual local axis of all these different objects here. However, sometimes you want to use a different tool over here or don't have the Move tool enabled, but you still want to see this gizmo. And this you can turn always on if you click on this arrow here under Viewport Gizmos, and then you can enable Move, Rotate, or Scale, or all of them together. I think Move makes most sense. And up here you can also change the orientation. Default will use the orientation we set up over here, as you can see. And then, no matter what tool you have selected over here, it will always show the Move manipulator, which can be quite useful. Sometimes the origin of your object is out of place and you want to change the position because it affects rotation, for example, and scaling, and also when animating the objects later on. In order to change this, you can enable the Move tool, and up here under Options you can enable Origin. Now you can simply move the origin wherever you want. You can even use the Rotate tool and all the shortcuts for transforming objects, because it basically acts as if you would transform an object, but in this case you just transform the origin. You can even combine it with any snapping tool, for example, Snap to Edge Center, so it snaps to the center of an edge underneath the mouse cursor. And when you're done with positioning your origin, you can simply disable this option up here so you can move the whole object once again. Here I have this head object and all these other objects are parented to the head, meaning when I move this, everything else moves along with it, but I can still move each individual child object on its own. However, now I realized that the parent object, the head here, is moved too far downwards. Now I want to move it up without moving all the child objects, which is not possible right now. In order to do that, you have to go to Options up here and click on Parents. This means if I press G and Z, I now can move the parent without affecting the children. So I can move it up a bit until it fits, and then I simply disable this option here, and now the parent works as expected. Here I want to change the distance between these two objects, but I don't want to move this one first. Remember how many centimeters I've moved this and then this one. Maybe we have even more objects selected. This can take some time. However, there's a quick way to do this. Select both objects, go up here to Options, enable Location, and now I simply press S for scaling, but in this case it won't scale the objects, it will just change the position. So I can easily change the distance between these two objects. This, by the way, also works if you quickly want to explode your mesh. Here I have this little bolt object, very important. I have local transform orientation enabled to see the local axis, and the Z-axis is pointing upwards. If this is not the case with your object, press Ctrl A and apply the rotation. Then the origin is moved a little bit upwards, so it's not completely on the lower end, but it should be set pretty low. Now enable snapping, or you can also hold down Ctrl to temporarily enable this, which I will do. And then let's enable face snapping. What this does, when I now hold down Ctrl and move the object, it will snap to the faces, but you can see the rotation will not align. So let's also enable align rotation to target, which is already better, but still acts a bit weird, as you can see. And to fix that, click up here and enable project individual elements. And now if I hit G to move it and Ctrl to temporarily enable snapping, you can see it will perfectly snap to the surface. And if I enable this all the time, I can simply Shift D, duplicate stuff, and then I can quickly add all these bolts to the surface. So here I still have face snapping enabled, and I have this bolt selected, which I showed you in the previous tip. And when I now duplicate the same object all over the place, certainly the blend file will get bigger because we add more and more data. However, you can also duplicate an object with Alt D. This will create a linked duplicate, as you can see down here. So that means we have two different objects here in object mode, but when I switch to edit mode, both elements will use the same mesh. Let's take a look in here in the outliner. We can see this is bolt number 5 and this is bolt. And if I open these up, this one is using the mesh cylinder 005 and this one here the same. If I click on this and make one change on one of these objects, the other one will change as well. One additional info here, modifiers won't be linked. That means if I have some modifiers here, I can change them individually on all these objects, which can also help to create variations of the same object. And if I disable all the modifiers for all these objects and tap to edit mode, then we can also see the changes on the other objects in real time. So Alt-D can simply duplicate them, and now all the objects will change at once. This is perfect if you have the same object all over the place. And then if you want to make quick adjustments, this works perfectly fine. Coming back to linked data as discussed in the previous tip, what if you forgot to hit Alt-D and press Shift-D a few times and then realizing, okay, all these meshes are not linked to each other. How can we change this? Simply select all the objects and as last object, the one from which you want to link the mesh to all the other ones. Then simply hit Ctrl-L and click on object data. Now the mesh from this object was linked to all the other ones here. So if I change something on one of these objects now, it will affect all the others. So our robot here is in a weird position, weirdly rotated, maybe it's even animated. And now we realize, okay, we want to make a change on the head because this robot has no nose and no mouth. However, editing something which is weirdly rotated is always a bit inconvenient, and I rather would move it back into the center of my scene and rotate it straight so that changing it is much easier. However, when I now move this out of the position here, place it in the center, make all the changes, and then I would probably have a hard time putting it back into the right spot. However, what we can do, we can make use of the linked duplicate. So let's Alt-D duplicate this, press Alt-R, Alt-G to reset the rotation and position. Now let's make the changes here. He needs a little nose and let's give him a little smiling face. And now when I go back to object mode, all these changes I made over here are now also done over here on this original object. That means we can simply delete the duplicate and all the changes here stay intact. And now our robot can smile again. So now you use some of the previous tips and positioned all these bolts here on different spots with the snapping and the linked data, but then you realize all of these bolts have the exact same rotation, and now we want to randomize the rotation. For that, go to Object, Transform, and click on Randomize Transform. Now down here in the operator panel, we can change this. We can on the one hand change the location. We can randomize the rotation, which we want to do. In this case, the Y rotation, as you can see. But we can even scale all the objects randomly, or click on even scale if you just want to change the overall size of an object. Pretty cool, but in this case, scaling makes no sense. So let's just change the Y rotation, and now all these bolts are rotated a bit differently. So we have two objects here weirdly rotated in space, and now I want to copy the location and rotation of this object to this object so that both objects align exactly on top of each other. For doing that, simply select the one first where you want to copy the information to, and then shift select the object where you want to copy the information from. Make sure that with N the sidebar is open. Under item you find the transform panel, and then simply right click on the location, and then you can either copy the single information from, for example, the Y-axis to the selected object, or copy all, which I use in this case. Copy all to selected, and then it copies the position, and then right click on rotation, copy all to selected. And now you can see this object copied the location and the rotation of this object. Certainly when I enable local transform orientation, it's important that the local transform orientation is correct. And to make it clear, for this operation, it will use the origin of the object and copies the coordinates of this to the origin of the other object. When working with modifiers, it can be quite time consuming to always go to the modifier tab, click on add modifier and search for the specific modifier. There's only one shortcut I know for the modifiers, which is Ctrl plus any number on the keyboard to add a subsurf modifier with a specific amount of subdivisions. However, there are some other modifiers which we are using a lot. For example, the bevel modifier, the mirror modifier, solidify modifier, you name it. And indeed, you can add a shortcut to these. Right click and click on assign shortcut. shortcut. However, since Blender is using so many shortcuts, I wouldn't necessarily recommend this because we might mess up other shortcuts, but we can add these to the quick favorites menu. So simply click on that. Let's also add the mirror modifier and the bevel modifier. And now all you need to do is press Q, and then you can simply use the mirror modifier and the bevel modifier. And of course you can change any settings over here. If you want to remove anything from the quick favorites menu, press Q and then right click, remove from quick favorites menu. And then next time you open this menu, these entries are gone. And of course you cannot only add modifiers to this quick favorite menu, you can also add any other function, for example the randomized transform. So this is especially useful for all the features which don't have a shortcut assigned to. Sometimes you want to apply all the modifiers from different objects, but you don't want to go through them one by one and apply each and every modifier. There are add-ons which allows you to apply all the modifiers. However, there's a tool in Blender which has a different purpose but also does the same. So simply select all the objects where you want to apply all the modifiers, go to Object, Convert to, and click on Mesh from Curve Meta Surf Text. So these objects are mesh objects already and no curve, meta surf or text objects. But when you click on that, it will convert the mesh into a mesh basically. And in this process, all the modifiers will be applied from all the selected objects, as you can see. So here a few of these objects are using the subsurf modifier. And now I want to change the viewport subdivisions for all of these objects. When I have these three selected and just change the subdivisions here, you can see that it will only change it for the active element, the one with a brighter outline, which I selected as last object. So it's not automatically changing the values for all selected objects. However, if you hold down Alt and change a value, you can see this will then affect all selected objects. This not only works for modifiers, this works for basically all values these objects share. So I can also select the location values, enter something here, and before I hit enter, I hold down Alt and then press enter, and then this will be applied to all selected objects. Or I hold down Alt and simply change something, and you can see that this will apply to all selected objects. Sometimes you have set up a stack of modifiers on one object and then you want to duplicate these modifiers to other objects to save some time. And this you can easily do. First select all the objects where you want to copy the modifiers to, and then with Shift select the one with the modifier. That means this one is active now, this has the bright outline. And now simply press Ctrl L and click on modifiers. Now you can see all the three objects are using the exact same modifiers. So here I have a simple object still with flat shading enabled. And now let's add a bevel modifier. A bevel modifier is always nice to add this beveled edges, and there the light reflects in this, so the whole thing looks way more realistic. By default, now all edges from the whole object are beveled. In my case, I set this to weight. You will learn more about the limit method in one of the next tips. And now let's right click and click on Shade Smooth. But now you see that everything looks kind of smooth and weird, so it doesn't feel right. And there's a quick way to fix this. All you need to do is to enable harden normals in the bevel modifier settings. However, you get a warning message down here that we also in the object data tab under normals have to enable auto smooth. And now all these weird shading issues will be solved. As you can see, the flat surfaces will look flat and the curved surfaces will look curved. And when you change the offset a bit, you can get really nice results, as you can see. So here I have this very simple cylindrical object, and now let's add the bevel modifier. Again, let's enable harden normals and auto smooth as shown in the previous tip. Now let's get back to the modifier settings. Let's change the offset a little bit so that it is smaller. And by default, as you can see, the limit method is set to none. That means every edge on the surface will get the bevel, which in most cases is not what we want. So we can try to use angle, which uses a certain angle to define where the edges should be beveled. So that means the lower the angle, the more edges will be beveled, and the higher the angle, the less edges will be beveled, as you can see. However, sometimes you don't get all the edges beveled which you want. For example, I want to have one beveled edge up here and maybe one on this edge. So what I would do instead, I would change this to be weight. That means I can go to edit mode, select all the edges or loops in this case, which I want to have beveled. like this. And then up here in the sidebar, press N to open this. Under item, we find the edge data. Make sure it's not the vertex data. And here we find the mean bevel weight. That means this we can set from 0 to 1. 1 means it will uses the full 0.02 centimeters, which I've set up here. If I set this, for example, to 0.5, it will only use 50% of this, and 0 certainly nothing. So you can define the strengths of the bevel modifier for each selected edge. So you can also go in here, for example, and say, okay, here I would want the effect to be not so strong, so I make it a bit smaller, and on others I want to have it stronger. And now you can clearly define which of those edges should be beveled and which not. Now let's have a look how we can use multiple bevel modifiers to stay very flexible while modeling. First of all, here in the Object Data tab, I have Auto Smooth enabled, so we can use the hard and normal feature from the bevel modifier later on. Then on the modifiers, I added a quick mirror modifier, as you can see, to mirror this shape to the other side. But this looks pretty harsh and edgy. Now let's add some nice bevel modifiers. First of all, let's create one. Tap to edit mode. Let's select these two edges over here. Press N. Set the mean bevel weight to 1, and let's change the limit method to weight. Now we added the bevel here on the side. Let's add a bunch of segments here, and let's play around with the offset until this looks nice. This already works pretty well. Now we want to add a nice bevel edge on the side here. For that, let's add another bevel modifier, and let's set this to angle first. Let's change the size, and as you can see in this case, this works quite well since here we have these very sharp edges. However, now we would be limited since we can't add any other bevel modifiers using the angle method nor the weight method, since the mean bevel weight is a global change which will affect all the modifiers which are set to weight, and similar to angle, this is calculated automatically according to the angle you set up here, so we don't have any fine control. However, we have a fourth option over here which is called a vertex group. That means we can define a specific group of vertices on the mesh which this bevel modifier should affect. So that means let's select this stuff here. And then let's go down to the Object Data tab, Vertex Groups, create a new vertex group and assign all the selected vertices to this group. This does involve a lot of steps, so if you want to make it faster, let's remove this and simply here, after selecting the vertices or edges in this case, press Ctrl G and then assign to new group, and then it creates a new group and assign all the selected vertices to this automatically. Now let's go over to the modifiers once again, and down here let's click into this field and choose the vertex group we just set up. And as you can see now, this edge over here is beveled. We can add a few segments if we like, and we can also enable hard and normals. Then we can play around with the offset. In this specific case, it also creates a bevel on these edges, which I don't want. This happens because these two vertices were added to the vertex group, and two vertices selected will result in one selected edge. So we have to separate these two vertices basically. So let's add a loop cut over here. The loop cut is selected, and then let's remove this loop cut from the vertex group, and then you can see this looks perfectly fine. So, and in this way you can add basically as many bevel modifiers as you like, assign them to different vertex groups, and then you are very flexible since you can change any value on all the different bevel modifiers. So here I have this head model of the robot. Let's right click, shade smooth. And as you can see, this looks pretty ugly and the resolution is quite low. So let's add a subsurf modifier with 2 subdivisions by pressing Ctrl 2. However, this leads to a very smooth result. What we can do, we can switch over to edit mode, select some edges, and then we have the mean crease. When we increase this edge will be sharpened when using the subsurf modifier. And to be honest, for years I thought that this option is totally useless, because when we switch over to object mode, we can see quite clearly this leads to ugly looking results. But since now we have a new option in the bevel modifier, this option is actually useful. So let's go to edit mode. Let's select one of the blue edges over here where I already added the mean bevel weight, which we discussed in one of the previous tips and which we will make use of in a second. However, to all of these blue edges, I also want to add the mean crease. What I can do, select this edge, press Shift G, and then we open up the select similar menu, and here I click on bevel. So all the edges where I added the mean bevel weight will be selected, and now let's simply increase the mean crease to 1. Now all of these edges are sharp, but they look kind of ugly as mentioned. And to fix that, let's simply add a bevel modifier, set the limit method to weight, which now makes use of the custom mean bevel weight, which were added in edit mode. And now let's also enable hard and normals. Make sure that in the object data tab, auto smooth is enabled. And now, as you can see, all these ugly artifacts will be removed and we have a crystal clear mesh with basically no weird stretching in it. And certainly you can play around with the offset of the bevel modifier, and then you have this perfectly looking hard surface object. Using a bevel modifier is awesome, however, combining this with a Boolean modifier can lead to problems. Let's press N. Here I have the Bool tool add-on enabled, which comes with Blender. Now let's select this cube here and then this robot head with the bevel modifier on, and then use the brush Boolean and click on difference. Now we have this Boolean object, and when we move it inside, you can see this will be cut off the other mesh. The current setup is said that first the bevel modifier will be calculated and then the Boolean. That means the Boolean is just cutting away the area of the bevel modifier. However, if we want to have the bevel modifier on the edges from the Boolean object, we have to invert this. So let's move the Boolean first and the bevel modifier after. However, you can see that when I move this around, the bevel modifier is changing quite a bit. And this has to do with vertices lying pretty close to each other. So the closer two vertices on the whole mesh are lying, the smaller the beveled edge will be, because we have clamp overlap selected. That means it prevents the bevel modifier from overlapping. Otherwise it would look like this and we can have a lot of weird artifacts. So clamp overlap is actually a good option. However, this can change the bevel modifier quite a bit. So let's go to a point where we don't see any bevel anymore. That means somewhere on the mesh there are lying two vertices so close together, maybe even overlap, so that we don't see any bevel. However, there's a fairly new modifier. Let's add this one. It's called the weld modifier. And let's move this above the bevel but below the Boolean modifier. That means the Boolean is calculated first, then the weld modifier, and then the bevel modifier. And all it does is merging vertices which are lying very close together. That means we can increase the distance to merge all the vertices which are lying pretty close together. Take care, however, if you overdo it, you can lose a lot of your details, as you can see. However, if you use very tiny values, close lying vertices will be merged, and then we get our nice beveled edge back, as you can see. This, however, does not solve all your Boolean bevel problems, but in many cases this can help a lot, as you can see. And now we have a Boolean with a nice beveled edge over here. Now, although the robot looks quite nice, this is still missing these typical straight sci-fi lines on the surface. For that, let's add a simple cube, scale it down, move it to the side here, move it somewhere here, scale it a bit wider. Let's hit Ctrl A to apply the scale to avoid any issues with modifiers and so on. And then with the Bool tool enabled, which I showed you in one of the previous tips, press N, select this cube thing first, then the head of the robot, and then under brush Boolean, click on difference. This stuff we know already. You can see this is now cutting into the mesh. However, if I now add a solidify modifier to this cube here, all the faces will have thickness, and this thickness is now cut into the mesh. And now we can play around with that in edit mode. Let's make sure that this front face, this lower face, and this face back here are deleted. Don't get confused, because right now the viewport display is set to bounce. We can set this to wire to better see what's going on here, but still be able to see through. And then let's simply select these two top edges here, press Ctrl B and bevel them. Let's add a few segments by scrolling the mouse wheel. You can certainly also do this by adding a bevel modifier to this object if you want to be able to change this later on. And now this was cut into the mesh over here. Make sure that we set this object to shade smooth, and also let's enable auto smooth just in case. Now we get this weird artifacts. Make sure that in this case the Boolean modifier is on top of the bevel modifier. That means first we calculate the subsurf modifier to get this nice smooth surface, then the Boolean modifier to get the cut, and then the bevel modifier. As we also know from previous tips, this Boolean is probably now destroying the mesh completely, and that's why we don't get any nice bevels here. We can try to add a weld modifier as shown before, move this above the bevel modifier, and this then merges some of the bad geometry. We can try to merge even more, and this is indeed helping a little bit. So let's try a value of 0.06, and if this line is too thick for your taste, you can always make it smaller by changing the thickness of the solidify modifier. Now when you select both objects and move them around, this can be quite slow, as you can see. That means when you're completely done with editing all the meshes and have saved a backup of your file, I would recommend to apply the subsurf modifier and the Boolean modifier, and probably also the weld modifier. You can apply the bevel modifier, but in this case you don't have to. Then we can get rid of this object here, and then we have this nice slice cut in our mesh, which makes the whole thing look way more beautiful. Let's imagine you have modeled your object symmetrically using a mirror modifier, and at some point you apply the mirror modifier. And then later you realize that you need to change something on the mesh symmetrically. However, the simple symmetry function up here is not enough because it's only useful when you want to change the existing mesh, but if you want to add something to the mesh, it won't work. In this case, what you probably would do then is to remove one half of the mesh and then add the mirror modifier again. However, you don't have to do this. We do need to add the mirror modifier, but we don't need to delete anything from the mesh. So let's simply move this up here. Make sure that the right axis is mirrored. X-axis is correct in this case. And now do any changes you want, like adding these super realistic arms here. All in all, this looks okay. However, in reality, the mesh is just overlapping here, as you can see. And in order to avoid this, we can add the bisect feature, which basically cuts everything away, which is at the mirroring axis here in the center. You can see this when I enable this button here. This is what happens. If it's mirroring the wrong side, you can click on this flip button and then everything is fine. And now, if you like, you can simply apply it and then you have a perfect mesh. No overlapping, no bad geometry. So you have modeled your object and now you want to mirror this to the other side, and full of excitement, you add the mirror modifier and then something like this happens. The mirror modifier is using the origin of the object as mirroring axis by default. You could define a separate object as mirroring axis. However, this is not what we want to do here. We want to change the origin. And here we use a tip which I have showed you earlier. Simply go to options up here, click on origins, and then you can simply move the origin, and this will also change the mirroring axis here. This might be not like super precise, but this is like super fast, and when your object is directly in the center, you can press N and then, for example, change the X location to 0, and then we make sure it's perfectly in the center here. Here's a quick and easy way to create array pattern. Add a mesh, a cube, then go to the Object tab, Viewport Display, and under Display As, click on Wire. So this object will always be displayed as a wireframe, no matter what you have set up here. Then let's hit Shift A and add a simple plane here in the center. Then let's select the cube first, Shift select the plane, then press N, go to Edit, and when you have the Bool tool add-on enabled, which is shipped with Blender, just enable it in the preferences. We click on Brush Boolean Intersect. All this does is adding a simple Boolean modifier to this plane using the cube as Boolean object, and with the operation intersect, the plane will now always stay inside the volume of the cube. And the cube now acts as our boundary. That means we can add an array modifier. Let's increase the count to 5. Let's disable relative offset, because relative will change the distance of the object according to the shape, which we don't want. So let's disable this and use constant offset instead. Let's set the centimeters to 200, which are 2 meters, since this plane has an edge length of 2 meters, and also enable merge. That means all the duplicates will be merged on the edges where they meet each other. You can also play around with the merge distance here if it's not merging perfectly. Then let's also copy the array modifier once again and change the offset to the y-axis. So we have this big square. Now anything I change here will affect all the other squares here as well. Now let's do a quick change. Let's scale this, for example. Then let's add some loop cuts here. Maybe move them down a bit. Select everything, Shift D, right click, then scale this along the z-axis -1. Then let's rotate this 90 degrees, and then we can rotate this all together, scale this up a bit so that it's pointing above the edges of the cube. And if we like, we can select all these edges here, and with Ctrl B and scrolling the mouse wheel, we add this smooth bevel. Now back in object mode, you can see that it cuts away all the stuff which is outside the cube. However, all the edges of the duplicates are not meeting at the right spot. So what we do here, we simply apply the Boolean modifier. We can always re-edit later on if we like, since the cube still is in place, but then the mesh is cut here, and then we can simply select all the outer vertices here. Then let's enable proportional editing, so we can change this more smoothly when I increase the radius here. And then I press S for scaling, Z for the Z-axis, and then type in 0. So everything is flattened on the same area. And then let's go back to object mode, shade smooth. Let's add a solidify modifier, make this a bit thicker. And if we like, we can also add a bevel modifier with harden normals and the normals set to auto smooth. Let's also change the limit method to angle, so it looks a bit more smooth. And now certainly we can play around with all the modifiers here. For example, we can increase the array count to change the size of the pattern. And you can always go back to edit mode, change anything on this one specific object here, and this will affect all the other duplicates here. And certainly in the end, you can also apply the array modifiers, certainly also all the other modifiers, and then you're able to edit everything all together here if you like. So yeah, go crazy with this method. Let's have a look on how we can quickly create a circular array. First of all, here I have this very simple scaled cube. Let's delete the two outer sides here. That's important. Then let's add a bunch of loop cuts here, like this, maybe some here as well, and some on the other side as well. And now we can go in here and really go crazy with the shape. Let's extrude this one here. Let's push this one to the inside, and let's also extrude this one here. Since we want to add an array, I don't delete these faces here because they will be appearing here on the other side. If I would delete them, we would have some open holes. So let's add the array modifier here. As you probably know, with this, you can duplicate the shape along a certain axis. When I press Alt-Z, you can see that we can see these edges here. That means these duplicates are not merged into each other. So let's enable merge. And now comes the magic. Let's add the simple deform modifier, which allows us to twist, bend, taper, and stretch objects. And in this case, we want to set this to bend, axis to Z. So it's using the Z axis to bend it around. And let's set the angle to 360 degrees. Now you get the idea on how this works. When we now increase the count of the array modifier, we can increase the size of this circular shape. Also, let's right click, shade smooth. Let's enable auto smooth. And the cool thing now, we can go in here and change anything on the shape we want. And this will nicely affect the whole circle. One little note here, you can see that the first and last object is meeting each other and there's still this edge which is open. The first last option here on the array modifier is not working in this case, so we have to add a simple weld modifier to merge this last open edge. And of course we can add a bevel modifier, limit method set to angle, and let's also enable harden normals, Alt-Z, scale this down a bit. And now you created an awesome circular shape and you are very flexible. By the way, if you want to have some fine-tune on the size, you can go to edit mode, select everything, press S for scaling. In this case, scale it along the x-axis, and then as you can see when I change this, it's also changing the size of the circle. And when holding down shift, you can fine-tune this nicely. And now let's thank our little robot here with a nice crown for all of his hard work. In the last tip, we created an array object which is deforming around a circle. However, sometimes you want to just duplicate objects around a circle without them to be deformed. Here we have this object, and now I want to place 3 other copies around the head here. In order to do this, first of all, let's go to the local transform orientation and check the axis. You can see this is rotated. So let's press Ctrl A and apply the rotation so that this is pointing straight up. Then let's Shift A, add a simple empty object. In the object tab over here, let's go to viewport display and enable in front. So it always will be shown in front of all the other objects, which makes it easier to select. Let's move this up, hit Shift S and click on cursor to select it to place the 3D cursor here. Now let's select this object, right click and click on Set Origin, Origin to 3D Cursor. It's important that the empty object and the origin of this object are lying exactly on top of each other. Then all we need to do, let's add an array modifier to this object over here, disable relative offset and enable object offset. And here let's pick the empty object. Now we want to have a count of 4. This number includes also the original object. And then all we need to do is to rotate the empty object, in this case 90 degrees along the z-axis. Now you can see these objects were duplicated 4 times. The nice thing here is that we are now completely flexible. That means we can add more duplicates. We can change the rotation if we like to match the new number, and we can even create spiral shapes if we move the empty up and down. And scaling the empty, as you can see, will also affect all the duplicates. So this trick has many other applications, as you might can imagine. Robot tentacles, for example. Talking about robot tentacles, now let's have a look at how I set up these robot tentacles here, which are basically fully rigged and super easy to control. So first of all, I have the local transform orientation orientation enabled. Over here I have the move tool enabled so I can see the local axis of the object. And here I created this very simple cylindrical object with a bunch of modifiers on it, subsurf modifier and a bevel modifier. Nothing fancy. Now in order to control this tentacle arm, we need to hit Shift A, curve, and add a Bezier curve. A path is also working, but to have better fine control, I recommend to use a Bezier curve. Then we get this curved shape. In edit mode, select everything, press S for scaling. Let's choose the y-axis, hit 0 and then enter. So we straighten the whole curve here, as you can see. And now let's make sure that one of these dots here, the center dot, is in the center of our scene here. Basically at the exact same spot as the origin of this object here. That's important. Then let's keep this object here selected. Then let's add an array modifier. If it's not duplicating into the right direction, make sure that you change this axis here, X, Y, and Z, depending on the local axis of the object. Then in order to make the array automatically fit along the curve, simply change the fit type to fit curve. Then let's click on this eyedropper and choose this Bezier curve. One little note here, when I go to edit mode of the curve, it always fit the length of the curve, but not the position of the curve. So if you want to have fit both, place a curve as I have described before. Now in order to see the curve through the object, let's go to the object tab over here. Let's go down to viewport display and enable in front. So it will always show up in front of the objects. And now we need to tell the array object to deform along the curve. For that, let's go to the modifiers, add a curve modifier, and here let's pick the curve as well. Now if it's doing something weird like this, make sure that you pick the right axis, in my case positive X, because the red arrow is pointing in this direction. And now if I go to edit mode, I can select these points here and move them around. And as you can see, the array will automatically fit the length of the curve. I can also play around with these handles here. The size will change the curve here a bit. And if the resolution of the curve is not high enough, go to the curve settings and increase the resolution preview U. However, the render U is set to 0. That means in render mode, we have the highest amount of subdivisions anyway. Now let's make sure that this is straight again. Let's select both points here, right click and click on subdivide so that we get a third point here in between to have a bit more control. However, in object mode, when we want to animate this later on, nothing happens, as you can see. So we need to add some control objects. For that, simply select a point here in the center, press Ctrl H to add a hook and click on hook to new object. Let's do the same thing for all three vertices here. Then in object mode, we can now select these hooks, move them around. We can even scale them to change the curve. And then we have full control on our arm here. One note here, you can see on one side, the curve is extending, and on the other side, it's not. If you want to change the side so that this side here is extending and this not, simply go to the curve, select everything, right click and click on switch directions. You can see all these little arrows here on the curve. This is showing the direction of the curve. And now, as you can see, it is turned the other way around. For this robot, I just changed the appearance of the empty objects. Go to the object data tab, and up here you can change it to anything you want, like a cube. And then I simply parent this empty object to the hands with Ctrl P. And now if I move the hands around, this empty object is following along, as you can see, but I still can scale it separately. And with this super efficient robot design, this robot is capable of serving us a cup of water. Here we have three spheres. They look kind of the same, but they are quite different. Over here we have the UV sphere, which we can add with Shift A, Mesh, and then UV sphere. However, when we add a subsurf modifier, you can see we get this weird rippling up here.